case, you encode it in UTF-8, and then you use the MD5, which is a hashing function, and make a hex digest. And that hex digest, this is an MD5, this long ugly string 2D0A2F51, that is a one-way hash of the email address. And if you go put that in to a thing, then if you know it, so that you can't figure out a person's email address from their gravatar, but you can from an email address figure out what the gravatar is. So this is not actually revealing the person's email address. And so that's why we're using a one-way hash, an MD5 of the email address. And then I just construct the URL, put the hash in the right place, put the size, that 60 parameter. If you take a look, where are we at? This :60 is the second parameter to this code we wrote, so that 60 is size. So that's why it says 60 right there, S equals 60 right there. And then I'm going to, use the format. I'm going to use format, and I'll put the hash in and the size in, and return that as a string, and that goes all the way back here, and then replaces this double curly brace. So all those double curly braces and piping, that's just code somebody wrote. In this case, the gravatar code is code that I wrote, and we wrote, or you could write, and it produces this URL. So it's a convenient way to put that URL in there, and it's really pretty, and it works out very cool. So you write this code, and it's in home template tags app tags.py, and then you basically have to load it in your menu. Where are we at? You have to go get app tags, and away you go. So that sums up how you can make a nice bootstrap menu and put it on your page through an extension menu, an extension mechanism. So we're going to extend it, and then boom, you make a page. Then you extend it again, and that puts it on the next page. So it's pretty easy. It's pretty straightforward. There's a lot of HTML, but luckily I hand that to you in the DJ free samples, and you're not going to have to modify that. It'll pretty much just work. You'll change what's in the menu. You'll be like putting different things in as the links and stuff. So you'll be working with this, but in general, most of the hard work is done. And as always, you can take a look at DJ free samples, just like we always do for inspiration. So I hope you found this helpful. Cheers. So now we're in the second half of our data modeling exploration. We've talked about one-to-many, and now we're going to talk about many-to-many. Just to remember, we are in the bowels of a Django application, and we're really very much talking about the model.py file and how we mess with that. We're talking a little bit about the shell and how we can sort of look at the model.py and store stuff in the database, how we can like migrate, make migrations, and update the database, and then read and write data from the database through the models. And so this, we're sort of narrowing in. Eventually we're going to see all the rest of the Django application, the views, the forms, the templates, and we've done a little bit with routing and a little bit with admin. But just remember that we're going to look at each of these pieces in turn and eventually make some sense out of them. So in this data model, which I think is a really cool data model because it shows two one-to-many relationships and two many-to-many relationships. One very simple and one a little bit more complex. Both the genre and the author are example of one-to-many. And just sort of foreshadowing, see the one ... asterisk there on both ends of the links? Well, that basically says one or more, up to an infinite. The other one's 0 ... the line's kind of covering it. 0 or more and 1 or more. So the one-to-many has 1 on the one side. Sometimes it has 0 on the, or 1. But 1 on one side and then 0 ... star or 1 ... star. So many-to-many is a different kind of creature. So remember how in the last modeling exercise, you'll notice I showed you genre and author, and then I kind of stopped talking about them. I only talked about language and book instance. So in this one we're going to talk about genre and author, and that's because genre and author are kind of problematic, because really each book can have multiple authors, and each book can be multiple genres. And so in that previous lecture I kept these really simple, and you see this syntax here where I'm just kind of making a spreadsheet, or another way to be thinking about it would be a single wide table with all my data in one table, but I'm starting to put commas in. And so when you have commas in a user interface, you think of this as perhaps a multi-select, where you have a list of things and you can highlight more than one of those things. And so anytime you sort of see this pattern, it's another form of replication, and that is that the Raspberry Pi book can be of the tech genre and the kids genre, and the Wizards Stay Up Late book can be of the tech genre and the thinking genre, right? Some books have one genre, some books have two genres, some books have one author, some have two, but then the problem is they might have 10 authors or 20 authors. And so how do we represent these things? And if you're sort of looking at either a UI or sort of a UI or just kind of a flat data table, you start seeing these commas. And as soon as you see the commas, you think to yourself, that is an indicator that this might be a many-to-many relationship. So if this were a one-to-many, not one-to-one, this was a one-to-many. This was a one-to-many relationship, sort of like what we did with languages. We would have a book, and that would have a genre foreign key in it that would point to a row in a genre table. And that would make some sense, right? But that doesn't make sense because we have to have genres more than one. And you could basically decide for your application developers that you can't have more than one genre. But the application developers would say, sorry, we're librarians, and we know that there's more than one genre, so you, the programmer, have got to come up with a data model that represents that. And so if this was a one-to-many, you could have like a genre ID, and each book would be able to pick a row out of the genre, and so they would sort of mark themselves. Now, this is another moment where it's a warning sign. And you're like, well, maybe we would just have two foreign keys, and how about books are only allowed to have two genres, you know? Maybe one's not enough, but two's enough. Let's make it three. And so, and people who are doing data modeling early in their career, they'll be like, yeah, I'll just make a genre ID 01, genre ID 02, and then later like genre ID 03, and away you go. And this is completely wrong. Because genres, of course, is a weird example, but if it's authors, there are plenty of books with 8 or 9, 10, 11 authors, right? And so this, when you see yourself thinking this in your head that like, oh, I'll just add an array of things here. No. And it has to do with it violates the basic notion of relations and connections and how you model stuff to the extent that you can with connections. And so that leads us to what's called the many-to-many. And so the many-to-many is a situation where you have sort of somewhere between one infinity and somewhere between one infinity on both sides. Now, what we need to do to model this is we can't really model many-to-many in a relational database. So what we do is we break it into two one-to-manys, and we have a junction table. You could call this the author book table. Later I'll call this the authored table, like, you know, who are the authors of? You could call it authors of. And it's a table that's a very short table, and it really just says, this author authored this book, this author authored this book, this author authored this book. And then within that, you can say for this book, who are all the authors, or for this author, what are all the books, right? So we call it a connection table, we call it a join table, we call it a junction table, and in Django terminology, we'll call this a through table. But its purpose is to have two outbound one-to-many relationships instead, and that basically is just our way of capturing a one-to-many. And that's why I said one-to-many plus one-to-many equals many-to-many. Two-to-many would sound good, but many-to-many. So here we are, and here are our two many-to-many relationships in our local library application. So a book can have many authors and an author can have many books, and that's what we're characterizing with this little one dot dot star, one dot dot star. And the same is true, like a genre can have be associated with many books. And interestingly, this zero dot dot star, that's special, where the book connects to genre and it's zero dot dot star coming out of the book. That means it's a minimum of 0. And all that's really capturing is that a book can have no genres, but a book must have at least one author. And whether that's true or not, that's what this data model is saying. This data model is saying all books have at least one author, but they have 0 or more genres, but they have 1 or more authors. And that's the subtle difference between 0 dot dot star and 1 dot dot star. And that's the kind of clever little application features that these applications can, these data models can capture beautifully. And we'll see in a second how that turns into a Django model that is then a business rule for the data. And so this is how it works. We're going to create 2 tables, the book table and the author table, and every row is going to have an ID, auto increment, primary key column. And then we're going to have these outbound foreign keys from authored. Again, the authored table is the start of the arrow, so it's the one that has the foreign key column in it, and the destination of the arrow is a primary key in that other table. Now, what we're going to do is, and we'll see how this works, is that Django allows us to create these kind of virtual attributes, and we'll name them cleverly. The name of them doesn't matter, but we'll basically say inside of author, we're going to have an attribute of books, which is automatically going to be populated by all the books the author wrote. And in book, there'll be this little virtual thing. It's actually computed. It's not stored. It's actually computed based on reading the authored table. It'll be authors, which is a list of all the authors. And so this is a convenient way, because in Django, they kind of want to hide this middle table. It exists. And as a matter of fact, you can write, drop my pen. Drop my pen. Pick the pen back up. Make sure the audio is still working. Is the audio still working? Yeah, it is. Audio's still working. Life's good. Sorry about that slight interruption. So Django tends to want to hide this through table, and you can actually define models where you don't even give that a name and it makes one up. It still exists. It exists exactly like it's shown here, but I would rather in my data model show you this table so you have a better understanding. But if you see other data models where they don't explicitly mention this and just have a many-to-many, and it actually makes this table up for you. So don't get all freaked out if you see a model that doesn't have the through table explicitly modeled. I like to do it. So here we go. So here we have some models. So we have the book field. The title is just a bit of the book. Then authors is a many-to-many field going toward the author table. That's the far one. But the through table is authored. So the intermediate table, the junction table, the through table is the authored table. The author is on the other side. The author has a name, and it has books, which is this kind of virtual set in there that's a many-to-many field derived pointing at the book table with a through table of authored. So the junction table, we mentioned the junction table the same in both of these, right? So this is going, from one to the other, and this is kind of going back. And these are like virtual, it's not data that's stored in the row of each row of the book table. It is data which is derived for you if you ask for it. When you retrieve a book, you can say, what are the authors of this book? It's a convenience in a way. And it also is telling Django about the foreign keys and where to store the foreign keys, and the fact that it's a many-to-many field. That's all setting up this stuff so that Django, when you start putting stuff in these tables, Django automatically puts the right stuff into those tables. And like I said, here's the through table I called authored. I thought that was kind of clever. And the through table is modeled as foreign key this way, foreign key that way. And so that's not a many-to-many. It's a foreign key, but I've named these and I match these things up. Now, the on-delete cascade is the same as the other one. These are two one-to-manys, right? The through table has a one-to-many going this way and a one-to-many going that way. And on-delete cascade and so just the whole idea of a book-author combination is if the authors are deleted, if you delete an author, you want to delete all the entries in the authored table that correspond to that author. If we delete a book, you want to delete automatically all the entries in that. And so that's what on-delete cascade means in the authored table. And that's clean this table up if things are deleted but from the outside two tables. So that automatic cleanup is done for us, which is quite nice. And we just request that with this on-delete statement. So, I don't know. That's a beautiful thing. That is a beautiful thing. It's so pure and so simple. And I don't like it when you don't put the authored table in there, because you can sort of do this and then it'll make the authored table up, but then there's certain things that don't work as well, and I don't like that. Okay, so let's just say we created this models.py file. Of course, in DJ4E samples, if you checked it out and you ran make migrations, it makes them all. But let's just say this is the first time you'd run make migrations, and then you'd see that it's creating the migrations, and then you do the migrate, which of course, as we talked about in the previous lecture, that is what takes from the migrations and then updates the database. And both the make migrations and the migrate are checking to see which ones have already been done. So make migrations is looking for changes or deltas in the models.py file, and the migrate is looking for deltas in the migrations. And again, remember that the list of the things that both of these is looking at is based on the settings.py file, and it's the installed apps variable in the settings.py file. So I put this note in because students are always saying, my make migrations didn't do anything. Well, there's one of two reasons. It either is not in the settings.py file, or it's already done. So I don't know which of those it is, but those are the two things to look for. If you think you're running a make migrations, and it's not running. It either already ran, which is fine, that's totally fine, or you forgot to add it to settings.py. So, okay. So here's just a few things that we can do in the shell, right? Again, Python 3 manage py shell. You got to run this from the folder that has manage.py in it, which is the project folder. Projects have many applications. And so, because the manage.py shell starts up and preloads, again, the manage.py shell reads all of the apps that are in settings.py, loads their models, and a few other things from those, preloads them. And so that's why bookmany.models exists at the very first line here, because Django, in a sense, has woke up and preloaded all of the classes and things that are there. So it's in a Django application, not just in a Python shell. So we import bookmany as the name of the application, and the models are book, author, and authored. So some of this hopefully is starting to look familiar to you. We create an object of type book model, the title's networking, and then we save it. Remember, save is the thing that transmits the in-memory object into the database and populates that ID field. And when you start linking these together, populating the ID field is very important. We do a Raspberry Pi book and we save that, and now we're going to make an author for Kristen and save that, an author for me, and we save that. And so at this point we have made two authors and we made two books, but now we have to connect them together. Okay, and so what we're going to basically say is we're going to create an authored record, a record in author, with a book connecting book B1 with author A2 and save it. Then book B2 connected with author A1 and save that. Book B2 connected with author A1 and save that. So that's throwing three records into the authored table, making those connections, setting the foreign keys. So like it's just reading the ID field from these A1, A2, and B1, B2, and that's like inserting records into the authored table in the book underscore ID and the author underscore ID, right? Now, remember that in book we have this virtual set called authors, and in author we have this virtual set called books. Again, that's not actually stored in the book table or the books table. It is generated by reading through the appropriate things in the authored table. That's how it's generated. So, if we say for book 1 dot authors, this is like that little virtual thing, and it reads all of the corresponding authors from the authored table, and then values just says actually go retrieve them,
And so now we see that the authors for book 1 is a list of just one author named Severance. Book 2, authors' values, is a list with Kristen and me. And then author 1, who's that? Author 1 is Kristen. What books did she write? Well, she wrote the Raspberry Pi book. We co-wrote that book. And then author 2, what books did he write? Well, he wrote the networking book by himself, and he's a co-author with Kristen on this other book. And there's all kind of other things that you can do, but you kind of get this idea that, you know, you don't have to do too much with the authored table, but and then once you got things all set up, you can sort of like walk the authored table without actually knowing it, because we preset these things when we made the data model, and said what the through table was. And so the through table is sort of a magic thing that's useful, but we don't really explicitly deal with it too much. Now up next, I'm going to show you a different example of many-to-many, just to sort of bring this home a bit. So now I want to show you another example of many-to-many from an application that's near and dear to my heart, and that's the autograder that I use for most of my online classes. So one of the things the autograder has to know is like who is in what course, so that we can track grades based on people in courses. And so this is the data model, and it's a little bit different syntax. You sort of see one-to-many. It's using this what's called crow's feet. And you see this little crow foot, and that's like a many when it sort of spreads out. And then you sort of have this one, and there's various little ways, and 1 or more or 0 or more. And so there's that's called a crow's foot diagram. But these diagrams ultimately are capturing the same thing, whether these relationships are many-to-many or one-to-many, and what the cardinality of each end of the relationship is. And this is showing a person table, a course table, and a membership table, and this is a very common thing that we have to solve in educational systems. And it's a little bit more sophisticated than the previous one, which I thought was beautifully elegant and simple, but I want to show you this one as well. And so what we have here is basically people are in courses, right? A person can be in many courses, and a course can have many people, so it's a many-to-many relationship. We create a through table, we'll call it a member table. We end up, just like before, with 2 one-to-manys pointing out, or many-to-ones pointing outward. So we have a person ID and a course ID in the member table. All 3 of these tables have primary keys of ID, ID, and ID. And then we put the little tiny sort of virtual set in here, so that at a person you can just look at a virtual set of their courses, and in a course you can say who are the members of this course. Now we're going to do one more thing that's a little bit different here, and that is often the simplest of through tables is literally an ID and 2 foreign keys. And as a matter of fact, some people, Django doesn't like doing this, but some people don't even include the ID field, and they just make the combination of the 2 foreign keys as a unique ID. And if you're doing databases directly, you can actually do that. But here's a thing that you can also do. So if you think about in a teaching and learning situation, people aren't just members of courses. They are members of courses, and they have a role. And is that role as a learner, a teaching assistant, or an instructor, or perhaps they're the departmental administrator, right? And that is an attribute of the connection, right? The connection between a person and a course is the membership, and oh, by the way, they're not just a member, they're a member with some metadata, okay? And so sometimes we add data to the through table, and it's actually quite useful, and it's really the only place to model this kind of data, because somebody might be in a course as a teacher, and they might be in a different course as a student, so you can't just say this person is always a teacher, or they're always a student. You can't say that. It depends on the context, and so that's why at the connection between a particular person and a particular course, we actually model the role that they have in that course. So here we go. So we're going to have a person in a course, and we're going to have a through table of membership, and so we're going to send these things back and forth to each other. And this membership is the tricky one. And so we have a foreign key over to person and a foreign key over to course. And we're going to model some information. We're going to model a created date at, and this is a datetime field. This is another feature that basically says, let's make a created underscore at, and dear Django, I'm not even going to set this value. Please, when I create this, a new record here, populate this at the current date and time, and if I make a change to it, change the updated at. And this is a common pattern in lots of tables to put these two lines in, and it's so common that we often call them the same field. So you'll look in somebody's Django model and you'll see created at and you'll see updated at. And so that's another thing we're modeling at the connection in the through table. And so the other thing we're going to do is have the role. Now, the example that you use in local library, they make this role, I think, a string, which makes me kind of like feel bad because I don't like vertical replication of string, so, even if they're sort of from a fixed vocabulary. So what we're going to do here is we're going to do something where we're going to create a set of integers and associate those integers with meaning and use them in the admin interface, etc. And so what I'm going to do here is these learner, IA, GSI, instructor, and admin are just integer numbers. And then I'm going to say, I'm going to make this little a tuple of tuples, or a list of tuples as it were. And you know, the learner integer maps to the string learner, so we can show that in the user interface. This here is a lot of UI stuff, so in the admin UI, this whole member choices thing affects the admin UI. When this is all said and done, we basically say the role is an integer field. And I like that because it's short and I love integers. How many times have you heard me say I love integers? Integers are short and efficient. And instead of this just being any number, it really is the choices are pulled from this thing, which is these possible numbers, which is 1, 1,000, 2,000, 5,000, or 10,000. And the default value is learner, which means it's a 1. So this is a nice... This is basically not, you could make it an integer field and we could code in our Python code these numbers and these strings, but there's a lot of value in using the administrator interface now and having these values known inside the data model rather than just coding them throughout all the Python code that we write. So when this is all said and done, what we have is two foreign keys, two outbound foreign keys like you would expect, a created at and an updated at that's totally maintained by Django for us, and then modeled at the connection a role, like are you a teacher, are you a student, okay? And so that's a little more sophisticated kind of many-to-many model. And we can talk to this in the Django shell, Python 3 manage.py shell. We import the models from the application models. This is really reading the models.py file from the many folder. Import the person model, the course model, and membership. Those are Python classes. We're going to make a person and save it. We're going to make a course and save it. We can check the ID to prove that. We can look at all of the members values. That's a query set, and then with nothing in it. And then we can create a membership, and we give membership.instructor. This is that number, right? I think that was like 1,000 or 5,000, I think what that was. And then courses C. Oops, how come it's not right? There we go. Courses C and person is P. That's taking from the P and C variable that we just created. We are basically populating the through table with the two objects from which we'll figure out what that foreign key is. And then we save it. We can see that it's been saved by looking at ID. And so we can see these things like C members values now. We can see that this is the person who is a member of that particular course, and we can see what courses Ted is in, and Ted's in Woodcraft. And so this is just another example using the shell to talk to some many-to-many relations. So up next we're going to show how we do these shell-like operations, but we're actually going to just write Python code rather than typing Python code. So we've been working with the Django shell and typing commands in to insert records and populate fields and create the both sides of many-to-many and then link them together. And so some applications that we're going to build, you're going to put up your super social ride-sharing thing that you just built, and people are going to start filling it with data. But other times you're actually building a website for which the data is already known. You might actually be reading a bunch of data and putting it into a database from some source. Maybe it's an API, maybe you're scraping or whatever. And so you have some source of data and you want to put it into the database. And you don't want to put it in by hand. And so we're going to talk a little bit how you can write a script to load data into your Django database, into your Django models, after you've defined those Django models. And so we're going to actually take some CSV data, we're going to read it from a file, and it's just comma-separated values, and we're going to use the course person membership model from before, and we're going to say basically, here's a person with their email address, their role, which is instructor or learner, and then the course that they're in. And what we're going to do is we're going to write a script to read through all those things and then insert and populate. Because you gotta, when you're making a many-to-many, you gotta like put both sides in and then connect it together. And so the code will be in DJ Free Samples scripts manyload.py. That's the code to load it, to read this file, and then create it, put it into DB-SQLite, informed by the data model in the many-to-many example that I gave you with the course stuff. Okay, so that's what this is. Now, running scripts is part of a feature of Django called the Django extensions. Now, if you've already done this through when you installed DJ Free Samples and you ran pip3-r requirements.txt, you already put this in, but it doesn't hurt to go into your virtual environment and type pip3 install Django extensions and make sure it's already there, because if it's not already there, then it will get installed. Otherwise, this whole script thing won't work, right? After you install it, you do have to put a little link into your settings.py. That's Django _ extensions in your installed apps. And there's documentation on how all to do this. So that's the first thing you've got to do. Once you've installed it with pip, you have to pull it into your Django application. So when Django first loads up, which is python3 manage.py, at that point that says pull this in, pull all these other things in. All your apps, your extensions, the Django features you need, etc., etc., etc. And that's in the project settings.py file. So Django extensions won't work if you don't put it in this file. Now, if you're running on Python Anywhere, of course, after you edit this file, you gotta reset your web. But I think you probably figured that out by now. We wouldn't have got this far if you weren't resetting your web server on Python Anywhere. The next thing you do is within your Django project file, you make a scripts folder. And you put this file, empty file, touch is the Unix command to create an empty file, scripts / __ init __py. This is just kind of a thing you do. And what it is an indication as Python is reading through these folders to say this folder contains modules that are suitable for importing. And that's just a signal, and I think later versions of Python make this less important, but we've always put this in. So if you're going to put like classes that are intended to be imported into some other application, we always put this empty file _ init init_py. So touch says make an empty file of this name. So our data file looks like this. It's just a CSV. Python has a great CSV reading thing. And it has 3 columns: the person's name, their role in the course, and their course. It's pretty small just because I want to show it to you. So here's the code that we've got. And we'll see in a second that you can't just run this in Python. You got to run this after that whole Django extensions says load up all the Django stuff and then run my code. As compared to just run my code. If you just run your code, that import of many.models person code membership, course membership is just going to blow up because it hasn't run the settings.py first. You can't do that, but python3 manage.py does do the settings, and loads all these things and makes it so that this import works. Because that's how you access the data models. And there's other things, like it's made the connection to the database, the DB SQLite, and figured all that stuff out. You don't write a single line of that, right? And that's all magically done sort of before you start, and all you have to do in the script file is make a method called run. It takes no parameters, and when the script starts, it's going to call your run method, so your first line of code is right there. So what we're going to do is we're going to open the CSV file, and we're going to use the CSV library, CSV reader fhand, and we're going to get a CSV reader. This is just an iterable thing that you can go read your way through this. And it parses the CSV and gives you a nice array out of the CSV, and if there's quotes in there, it knows about that, and escape characters. And CSV files are kind of complex. The one I showed you was super simple, but you may quickly run into a CSV that's got UTF-8 characters in it, or who knows what's in it, and you want to use this CSV reader rather than just doing a split on commas. The one I gave you, split on commas, will work, but you don't really want to count on that. You really want to use CSV. And again, it's all built into Python, so Python's awesome, so away we go. Now, the first thing we do before we get going is we take the person class, .objects is kind of like a thing we say after the class, .objects all, that's like a filter, and then .delete. That is kind of like a delete from person table. And then we're going to delete all from the course table, and we're going to delete from the membership table. Now because we have, so if you go to the person table, the membership table, and the course table, if you recall, there was a on-delete cascade for both of the foreign key relationships coming out of the membership table. So probably, if all was well, after the person objects all delete was done, and the course objects all delete was done, the membership table would likely be empty. Because if you empty out the course table, empty out the membership table, and you have on delete equals cascade, those deletions in those destination tables will percolate back into the source table and cause those rows to be deleted, just like so this is kind of redundant. Membership objects is kind of redundant because of on-delete cascade that we put into that data model. Okay, so we open our data. Let me clear this out. We open our data. We get a CSV reader. We wipe out the data, the old data that's in those two models in our database. That's in the DB SQLite file. And then we're going to read all the rows. Okay, we're going to just print the row out, which just is a tuple. It's a list actually. And then we're going to call person.objects, and this is really cool. A method called get or create. This is either going to retrieve a row that matches the email of the email address, because the email address is the 0th element because it's the first element. If it's not there, it will create it and then retrieve it. So this is kind of like Python's, this is very much like get in dictionaries, where if you use get the right way, you can basically increment or create something. In this case, we're loading it if it exists, and if it doesn't exist, we're making it and then we're loading it. And part of what we did is we declared this email as unique. And so it's going to load it up, and we do that for both the course and the person, and we actually are returned a tuple. The P and the C are the objects that we're going to get back for person, and created is a Boolean that tells you whether or not the getter create did a get or it did a create. If created is false, that means that there was one and we loaded it. If created is true, that means there wasn't one and we created one. Now, in our situation, we really don't care whether it was created or not. And so when these two lines are done, we know that we have a person associated with the email, the first parameter, and then a course associated with the course title, which is the last parameter. And if you look back at the CSV, you see there's redundancy, right? There's redundancy, or replication. Python, Python, Python. Django, Django. SQL, SQL. Jane, Jane, Ed, 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 Sue. And so we're only going to insert Python once, and then we're going to use the same Python over and over. Because even though there's vertical replication in this data file, we're not going to have vertical replication in our person, membership, or course tables. So there's no vertical replication allowed. No vertical replication allowed. The world is full of vertical replication. Good data models are not. That's pretty profound, actually. Okay, so at this point, we have the two records in the two tables on the sides. P and C have those values. Now, what we're going to do is we're going to figure out what the role is. Now, membership.learner, learner was just a constant. That was the number 1 if you go back and look. And then we say if row sub 1, which is rows a list, which the row sub 1 is the second thing in the list, is I, i.e. it's an instructor, then we're going to make our role be instructor. And then we're going to create a membership object using the role, that's just a number, the person is an object, and the course equals C, it's an object. So we're going to make that, it's still, and we get the variable m back, that's still sitting in memory, and then we save it, which then sticks that through table record or the junction table record into the membership database. So this is either going to retrieve or create, and then this is going to add the membership record. And before we started it, we cleaned everything out. So it's a pretty simple loader. There's lots of things you can do. I mean, I think if you were going to do this yourself, you would probably play around a little bit in the shell to make sure that statements like this would do what you want it to do. And then you'd write a nice little Python script and so that you could automate it so that you don't have to do it by hand for, 20,000 records. Right, here is just to remind you, this is that model, right? Learner, instructor, those are just constants, and that's what that did. So you run it, and recall that it prints the row, and so the row is just after the CSV reader parses it, it's got the three things, and one at a time it inserts or retrieves. And then it looks at the middle one to see what the role is, and then it creates a membership record and stores that membership record in the database. And so it's a pretty easy pattern to follow. I'm sure the stuff that you're going to write will be a little more complex. I kept this simple so that it would fit nicely on the screen. So here's just playing a little bit after all that stuff's been loaded. We can take a look. Again, just so we can type interactively, we got to go into the project file, the project folder, GJ free samples, and run the shell using manage.py. We can import our models. We can say person objects values. That basically says select all the records from the person table and give them to me. We can retrieve pk equals 1. pk stands for primary key. Say get the first person. What's their email? That'd be Jane. We can say, for Jane, what are the courses? The courses is that virtual set that is querying the join table, the through table, and pulling it out, but we don't think about it that way. We just like, oh, this is a magic set that's always there. So x.courses.values says, what are the courses that Jane is a member of? And Jane is a member of Python and SQL. So let's go to get a course, right? The second course objects get pk equals 2, so that's the Django course. And then we say, oh, let's go look at the members values. And so that says, who are the members of this course? Well, Ed is a member, and Sue is a member, right? So this is the members of the course, right? There's courses, course members, and then user courses. And so we've looked sort of from the outside, we've kind of looked through the through table to this list of things on both sides. So that's a thing you can do, but sometimes you want to actually see that data. The one thing we did in this membership is we actually modeled data in the through table. So what we're going to do here is we're going to grab a course, right? And we're going to say, okay, go ahead and get course number 2, and then membership set. That basically now we're looking at the through table, give us all the things of the membership set that are associated with this course, course Y, get them all and get the values. And so that basically is going, now we're going to see the records that are in the membership set. So we see them all, right? We see that person ID 2, course ID 2, the created date dat, the updated date, remember updated dat, those are automatically put in there. Remember we talked about them? You just say auto add equals now and auto update equals now. But you also see the role value, so we can read the role value. So this is the way we see, oh, we're in this course, and now we see who's in this course, and are they a teacher or are they a learner? And so we can dig into the through table using this kind of syntax. So that's quite a bit of a romp through one-to-many and many-to-many relationships. Data modeling, like I said, you can learn data modeling basically in a few hours, and you can spend your life crafting amazing data models. And I love it. I just find it really rewarding to build cool data models. And it's not that hard to build really good ones. I mean, it just amazes me how many people who are really smart that can't even build a basic good data model. Again, don't replicate string data, especially when it means the same thing, right? We have the concept of primary keys, which are in each row. We have foreign keys, which point at a row in a different table. And then we have the one-to-many relationships and the many-to-many relationships. And our local library application is a simple data model, and yet it does a really good job of giving us examples of each of these things in action. Hello and welcome to our lecture about JavaScript. JavaScript is another programming language, and if the Python is the only language you know, it's quite a bit different than Python. So JavaScript was originally designed as an addition to HTML and CSS, and it really started as a programming language inside of the browser that runs right in the browser. Even though it's named like JavaScript, like Java, it's really more like Python in how it works, except that it has a C-like syntax. And it's really an amazing language, and for a lot of people, it's their number one language, their favorite language. And so it's worth learning JavaScript even if you love Python. So JavaScript is an interesting language in that it was built very quickly, in 10 days in 1995 by a fellow named Brendan Eich. Brendan was a PhD in physics, and he knew a lot about programming languages and formal languages and how to build compilers really fast. And so the idea was to make a sort of a subversion of Java, like a lightweight version of Java, and put it in the browser. Today, it's gone through a standardization process, and it's called ECMAScript. And so if we were to take a look at the history of programming languages, you know by now, you know Python, right? And Python is a great language, and JavaScript is the other language we're going to learn here. And this just sort of puts them in some context so that you understand a bit of the influences. So in the very beginnings, in the 1950s, we programmed in assembly language. And then most computers, all they could do is numeric calculations very well. And so languages like Fortran came along. There's lots of languages, and sort of if you go back to the 50s and the 60s, people were inventing languages all the time. But a language that really, for me, changed everything was the C language. Invented in 1972, and I still want to do a really cool class on C. C is not a good language to write everything in. It's very much like assembly language. It mirrors how computers really work, which is kind of different than how we program computers in a lot of ways. But the other thing that C was doing was it was acknowledging that computers were less and less about numerical computations and more about strings and words and messages and things like that. So if you it's probably 95% of the calculations in computers have to do with moving data around, not numbers around. And C was great at that. So all the languages I used up till I started using C, they were kind of a numeric system that was sort of fighting to do characters well, and C was a very well done character system. And so it became the language. C is the language that's a kind of the mother language of all this. It's the Linux is written in C, Python is written in C, PHP is written in C, JavaScript is probably written in C. And so it's like the lowest level language that we go to these days. And when you're writing a language and you want it to be fast, the implementation of that language is often written in C. C++ came from C as an object-oriented variation, and we talked a lot about object-oriented Python. We're going to talk about object-oriented JavaScript coming up. And so C++ influenced a whole lot of systems that had to do, in a sense, C++ influenced Python as well. And so C++ has added an object-oriented layer. It's actually probably the least object-oriented of any of these other languages on here, but it had object-oriented concepts. C# was Microsoft's version of that. Java was open source, the thing that became the sort of progenitor of JavaScript, but again, they're not as related as you might think. It's really, JavaScript came from C more than it came from Java. There's a few things that are imitating Java. And so all of the things above this line are semicolon and curly brace. They use semicolon and curly brace to end lines and to begin and end blocks. Curly brace, beginning curly brace, and end curly brace. And then there's this other set of programming languages that don't use semicolon and curly brace. And C was the first language that did the semicolon and curly brace. And so these languages that are kind of below this line, Bash, Perl, Python, and PHP, are really, actually PHP is a semicolon and curly brace as well. Python is the language we've been learning, and it's really the odd language. So we're going to learn a language that's in the category that makes it easier for you to learn C or C++ or Java or Objective-C. And so this is worth learning, even though you know Python. There was another movement that was sort of C as a very high-performance language and really aimed at computer scientists to build complex systems like Linux. But then there were languages for like the end user that just got work done but weren't seen as like super performant for professionals, etc., etc., etc. And so Bash, which is the Linux shell where you're typing CD and LS if you're familiar with that. Perl was a report generation language that introduced the concept of associative arrays, and most people joke about Perl. I don't like Perl because I can never read my code after I write it. I can write it, but I can't read it afterwards. But it introduced a lot of wonderful concepts like associative arrays, which we would call dictionaries in Python. And Perl, it really definitely influenced Python because of its ease of programming. So what Perl was really good at was allowing a person with very little formal training on data structures to be able to use associative arrays and nested associative arrays to create pretty sophisticated data structures. And Python came along with that, and PHP also, original PHP stood for Perl Hypertext Processor. Now it doesn't stand for that, but Perl and Python and PHP are in this category of sort of interpreted, easy to use languages with strings that work really nice, and they just make life a lot easier. In languages like C, strings are very difficult. So if we take a look at this, right, we've learned Python and we're going to learn JavaScript next. And so we're moving in, but again, JavaScript you can think of as unlocking a whole bunch of other languages. And so it's worth learning it a little bit, even though in this class we're not going to go into any great detail, because mostly you're going to be cutting and pasting JavaScript and then tweaking it and reading it and debugging it. So we're really not focusing on writing too much new JavaScript. So there's a couple of situations where you'll find yourself writing some JavaScript. One is augmenting HTML. That'll be the first thing we'll do. There is this thing in the browser that runs JavaScript, and the way it interacts with the browser's UI is through the document object model. You can add a library like jQuery to make that interaction easier, because the document object models aren't as portable across browsers as we would like sometimes. And then if you keep going, you find that you're building more and more of your application logic in the browser. And so they say, you know what, I just want to write the model and view part, the controller and view part in the browser in JavaScript using a templating language, and you can use like Vue or React to do that. And then if you keep on going, you can act JavaScript is just a language, and they've implemented it inside the server using as a server-based language. And we would use Django and Python as our server-based language, but you can actually write your entire application front to back in JavaScript and use something like Node to run the server side of it that's actually talking to the database. So there's lots and lots. JavaScript is just like you're opening the door into a lot of really wonderful capabilities. So like I said, it is in the syntax family of Java, and that is that it has semicolons to end lines, white space doesn't matter, open curly brace and close curly brace, start and end blocks, whereas in Python you just end a line and you indent to indicate a block of text, and you de-indent to indicate the end of that block of text. Now, I will admit that Python is not my favorite syntax. It is my favorite language in that I like its libraries, I like how it thinks about things, I like its object-oriented patterns. I like a lot about it, but I do like my curly braces because for me, I like to see the beginning and end of blocks, whereas in Python, you only see the beginning, but that's okay. I'm just saying that now you're going to see some of this syntax, and it's going to look, if Python's the only language you know, it's going to look quite different. If you know Java, it'll be like, yeah, of course I know that. I've been programming that for a long time. So up next, we're going to talk about how we work with JavaScript when we're sitting in a browser. So now we're going to talk about how you use JavaScript in a browser. And as I said before, this is just only one of the possible ways that you might use Java. But this is pretty much what we'd call vanilla Java or basic Java or Java without Vue or Java without jQuery or Java without Node. This was the original JavaScript purpose, right? It was to be in the browser, augment HTML. So here we have a happy little bit of HTML. We got some HTML, you got a body, you got a paragraph tag, and we got this script tag. So the script tag says we're moving out of HTML as syntax, and we are then writing some JavaScript code. And we are talking to the document. Document, the DOM, is in a sense that part of your browser that's like the pixels you're seeing. And so this JavaScript code can write to what you're seeing on the screen by going through this this variable called document. Document.write writes onto the screen. And so if you take a look at this code, it's coming down. Out comes the title, out comes the body, the paragraph comes out, then it drops into JavaScript, and then this little string gets written out, then it goes back in. The no script tag is in case there's no JavaScript, which is really rare these days, and then the paragraph comes out. So the point is that this has created a 3-line web page. The first and the third line come from HTML, and the second line comes from JavaScript. Not that this is a particularly useful example, it just points out that JavaScript has access to the screen when it's running inside of a web page. That's powerful, and we're going to drive a truck through all that. So whenever I learn a new programming language, the first thing I got to do is print a debug statement. And the debug statement is called alert. And you say alert, you put a string in it, and it stops. It stops the program, and you have to press OK, then it continues on. So that way I'm like, did that code run or not? And I just put a little alert hello world in there, and then poof, up it goes. And then it just pops up a little dialog, and you press OK, and it continues. So that's really quite nice. And so here's a little example of that, where we're cruising along. The paragraph is written out. And one of the things that you'll notice is that this alert box actually stops the JavaScript. So we switch into JavaScript. The browser is still parsing the page, and you'll see sometimes the little spinner is still spinning. So it stops. It puts up the alert dialog box, here I am, and waits until you press OK. And in a sense, your browser is paused at that point. Because literally, it doesn't know what you're going to do, and this JavaScript has every right to change every bit of this page because the JavaScript is in the page using the document. So it pauses until you press OK, and then it picks back up, and then and then it will write hello world, and the second paragraph will come. But alert, you just stick it in your JavaScript, and whatever's happening, bang, it stops right there, and everything stops. And so it's a pretty cool thing. And so you can't use it too much, you can't use it in a loop, and if you do it too many times, your browser will like, why is this page throwing up so many alert boxes? But in a pinch, it's the simplest thing. So there's three ways to get JavaScript into your web page. One is inline in the document, and that's what I just showed you with a da-da-da-da script, da-da-da-da slash script. It can be, we've done this before, it's part of an event and an HTML tag. I'll show you that. Or you can put the JavaScript in its own little file, usually ending in .js. So here's the second one. This is the one where we're putting in an onClick method. And so we've been doing this, right? We've been doing onClick methods where we'll have an href and then onClick and then say something. And in this one, this part here in the middle, that is just JavaScript, and that's why it has semicolons to end each line. White space doesn't matter. This isn't Python. Don't need new lines, etc. So when we click on this Click Me button, that is going to start running this code. Now the page is already fully rendered, and the Click Me button is waiting to be clicked. And on click, that's when a click happens, event-driven programming. Then it runs the alert, pauses. Better change the color there. It runs the alert. How come I can't get it to be yellow? There, it's yellow. Clear it. Go back up and be yellow. Thank you for being yellow. So you click on it. It runs this JavaScript, which runs the alert, which pops the box up. Then you press the OK, and then it continues on this code. Now the return false is telling the anchor tag not to follow the link, right? And so that basically says, I, the onClick method, have processed this particular click. And so that's what the return false does. So we are basically just have JavaScript in the middle of a tag that's triggered when an event happens. So event-based programming. The other thing we can do is we can make this in a completely separate file. So we're going to have this file called script.js. Now it doesn't need a script tag because it knows that it's JavaScript, so that's just code. This happens to be one line that's got a document.write hello world, and now we embed it with a script tag and a slash script, but now we just say source equals script. It pulls it in, it loads and runs and parses that whole thing, and as a side effect, it writes out, one paragraph hello world and the second paragraph. And of course, usually this isn't doing work. Usually this is defining a bunch of functions that we're going to use later. And so usually this is script.js is a function. So we're kind of loading a library of functions that we're going to use later. But I just put this document right so you can kind of see when it's happening as the document is loading. So in any programming language, we can make errors as a programmer, right? We can make syntax errors. The problem is when you're looking at a web page, and in that web page there's a JavaScript syntax error, they decided a long time ago not to bother the poor user with a JavaScript syntax error. Because really the person, unless you're writing it in the first place, the person looking at the screen of, Amazon.com or drchuck.com, if I got a syntax error in drchuck.com, why tell you that there's a syntax error? So what it actually does is it just like, well, I guess I'll stop running the JavaScript because it's got a problem, but I'm not going to tell the user, which means my page is broken and I don't even know that. So it stops. And so syntax errors happen and it just stops the execution. So let's take a look at a little example here. A little example where we have two chunks of JavaScript. We come in, we got the first one, and this first one has a syntax error. Okay? And that means the alert's not going to work. Now what happens is it in effect ignores everything after that point. If it's executing through a script file, it might be defining a bunch of functions. If it finds a syntax error a third of the way through, the other 2/3 don't matter because it has stopped parsing that file until the end of the script tag. And then when it sees a new script tag, hope springs eternal, and it starts parsing it again. And so that's why when this page runs, you see first paragraph, this goes, blows up, which means it skips down to here. Then you see 2 paragraph come out, and then you see the alert second time. You never see any of these alerts because that error is on the first line of the JavaScript, which invalidates the rest of the JavaScript, but until another script tag. And sometimes what you're doing is you're like including one library, another library, and another library, and another library. If you have a syntax error in that library that you're including, most of that library won't actually be activated, right? And but it doesn't mean if you have like 5 libraries that you're loading with 5 script tags, just because the first library has a syntax error, it can still load the other four libraries. But it's just, it punts. There could be hundreds of lines of code here, and it all is for naught because it saw a syntax error and ignored the rest of it up to the end of that script tag. Now, the end user can't see the error, so when you're doing software development, you got to put in extra effort, because when you're like writing code and hitting refresh, writing code and hitting refresh, well, yeah, that's the user hitting the refresh in the browser, but if you're writing JavaScript, you want to see what's wrong. And so we have places that we have to look to see if there are actually JavaScript errors in our code. And once we start developing JavaScript, I assure you that there will be errors in your code. There's always errors in my code. And so all of these situations, whether all these browsers, Firefox, Chrome, Safari, they all have some kind of a web developer console that you unlock. And then you can go, there's always one of these tabs that says console. And console is all the error messages that are coming out. And so if you made that same bit of code and you had the console turned on, you would see a happy little error that says syntax error on line 3 of that file. I mean, it would just run the OKs later in the file, but it will tell us that. So you'll find that once you start developing JavaScript, you're making a big mistake if you don't have this little developer console open almost all the time, at least to the JavaScript console, because that's how you debug your JavaScript. It'll literally just like silently, you're like, I changed something and nothing happened. I changed something and nothing happened. I'm going crazy. Well, look at the console. You changed something, but there was a syntax error above it, and so it didn't matter what you said after that. It really ignores everything after that. So that's why it's so important to have the debugger console doing all the time. Thankfully, all modern browsers have a good debugger console. In the old days, Firefox was the only one. They had a thing called Firebug, which was this console, but you had to install it and add it, and it's a person wrote it as an open source project, and it got so popular that people just put it into the browsers rather than making you install it. So it was pretty cool. So back to debugging, there is a function called console.log, and it allows you to log variables and strings and whatever. And unlike the alert, it just shows up in that console. So you can put it inside of a loop. You don't have to press OK. It doesn't stop anything. It's really more of a debug print, right? And so in this particular example, it just runs. It doesn't stop. The alert stops everything. And so I use the alert like, what is going on? But if I'm really debugging something like in a loop, I'll use console log. So it comes in, console log comes out, it says alert, I clicked on it, so you don't see that. The second log comes out, and away you go. And so this is a better debugging mechanism. And if you look at systems that I've built, when I have really complex JavaScript, I will sometimes leave console log statements in it. So if you use Sakai, and you're at a school that uses Sakai and you do console log, you will see error messages in your production system that I left in there because of the parts of the code that were the JavaScript was so tricky. I'm like, I want to be able to talk to you if your stuff breaks, and I want any developer to be able to pop this window open and get a clue as to why some of the JavaScript stuff is breaking, because there's just so much complex JavaScript in it. And so I leave a few little debugging clues, and if you go into the auto grader, you can watch this. And I just like debugging, and it's sort of not all that costly. I don't put a ton of them in because then it looks a little sloppy, but yeah, I do put a few console logs in. So so you can use a debugger. It's a full-featured debugger. You can view the source. You can inspect. So you probably by now have figured out how to inspect elements, so you can look through and what you're looking through there is the document object model. But they also have a full-featured debugger where if you're looking in the source code, you can go on to the line that you're interested in and click, and then that will set a breakpoint. And but it doesn't, but usually the code's already executed, so you have to set the breakpoint, then you got to refresh the page, and it remembers where you set the breakpoint, and then it stops it. Okay, and so you kind of set the breakpoint and then hit refresh. You'll figure it out, because by the time it's all done, it can't go back in time. It's past that line, so you have to see the line, set the breakpoint, refresh the page, then it knows to breakpoint, catch the breakpoint as it's going by, rather than going back in time, because it doesn't remember. It can't run time backwards, just forwards. So that gives you a little sense of what it is like to do JavaScript in the browser. And now we're going to just look at JavaScript as if it were a regular programming language, and this applies whether it's in the browser, in the server, in Vue, or whatever. So now we're going to talk about JavaScript as a programming language. Now we're just going to talk about like the syntax. So we'll start out, say, with comments. So I love the comments in JavaScript. There are two kinds of comments, and they have to do with what languages did the influencing. And so the /*/ is a multi-line comment, right? So this is all comment from here all the way to here, and you can have new lines. This is great for writing documentation. That comes from the C language. Java also supports it as well. And then the C++ language has / to the end of the line. Well, that's much more like the # comment in Python. But I like both of those styles. I like using these for documentation sections, and I like these for short comments. So nice. Thank you very much. White space and new lines do not matter. Statements end in a semicolon. It turns out that that's not technically true, but if you just pretend that all statements end with a semicolon, then if you move to Java or C++ or C or PHP, then you're not like, oh, when do I have to put the semicolon on? Well, in those languages, you have to put it on just about everywhere. So just put semicolons at the end of every line, and you can just pretend you're writing C. And then when you get to C, you'll be like, oh, this is just like JavaScript, even though on the implementation, it's very different, very, very different. So here's just an example of some really nasty JavaScript where, x equals 3 plus 5 times 4 on 2 lines, and then this line's jammed up and console.log. That's okay. It just doesn't matter. I mean, JavaScript and these C-style languages just don't care what the white space is. They're looking for characters, blah, 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 semicolon. That must be the end of the line. Blah, 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 semicolon. That's the end of the line. So just the new line is just like another space-like character ultimately in these languages. Variable names are kind of normal. They can start with letters. I mean, they're letters and numbers and underscore and $, but they're not supposed to start with a number, and they are case sensitive. Just please. We use case sometimes as a signal because different kinds of variables, we like either camel case them or all uppercase. I use case to signal things. It turns out that because JavaScript sort of saw what PHP and Perl looked like, they allowed $signs at the beginning of variables because PHP and Perl are the places where $signs are allowed. But when people started writing JavaScript, they wanted to be more like Java. Java doesn't allow $signs in variables, and so there was kind of like this unwritten rule, which we will come back to, of just don't start a variable with $sign, even though JavaScript allows it. Just kind of don't do it. It's not cool. String constants, single quotes and double quotes function the exact same way. I like that a lot. Stylistically, what I tend to do is I tend to use single quotes as much as I can in JavaScript, because ultimately double quotes are part of HTML, and when I'm mixing my HTML into JavaScript, I tend to want to look at it and say that single quote is a JavaScript quote versus a HTML quote. So if we take a look at this little code, you see like this text equal JavaScript, that's in double quotes, and it has to be. So the 1 line and 2 line, I could use single quotes or double quotes for that. But for me, I try to use single quotes as much as possible when I'm in JavaScript, so I can take a look at this code and know HTML, JavaScript. If I'm in double quotes, I'm generally dealing with HTML. And because JavaScript is sometimes writing HTML, it's writing double quotes into the document because it has to, because that's how HTML requires it. So I have a single quote string that has a double quote in the middle of it because I'm writing HTML in JavaScript. That'll make more sense to you later. So you can do either one, and you'll see examples where JavaScript just uses double quotes, but I prefer single quotes as much as I possibly can. Numeric constants are pretty much like every other language, but there is only one number type. In most languages, there's like an integer and a floating point. Sometimes there's double and float. There's different kinds of long integers. In JavaScript, I think in a way they were smart, and they basically had made one type, one numeric type called number. And so, for example, if you take 5/3, that is a floating point number, 1.666 repeating forever. If you want to turn that into an integer, you just truncate it, like math.trunc. Math is a library that's in JavaScript. Now, when you get back an x, it's still a floating point number. It just is shown as an integer because you've chopped off the decimal part. And so you have to be careful because they're really floating point numbers. Every one of them, some of them are shown as integers when you print them out. But in general, there are no integers in JavaScript. So there's a whole bunch of operators: plus, minus, multiply, divide, truncate. You know, those are pretty much like every other programming language. More operators like the modulo operator. Modulo operator is the %sign, and that is the remainder operator. So 45 divided by 7 is 6 remainder 3. And that remainder, 45, 7 is 6, 42, 3, remainder 3. That 3 is what goes there. So division with truncation will give you the 6, but the remainder will give you the 3. And it turns out that modulo is really quite useful. Like if you want to do something every 100th time through an iteration, you take the iteration counter like 1, 2, 3, and if you modulo 100 and the result is 0, remainder is 0, it's an even multiple of 100, and that means every 100 times you can do something. So we like modulo. There are side effect operators. Oops, come back. There are side effect operators. K++ says retrieve K, have it be part of an expression perhaps, and then add 1 to it, store it back down. So if I say K++, it says 3, but then afterwards K has become 4. So after it retrieved the K and printed it, then it turned it into 4. There's a very few places that we actually use these, and then we use them all the time, but in general, you can hurt yourself if you write too much of this stuff. There is a pre-increment minus K, and that says subtract 1 from K, and then print it out, which is 3, and then the 3 goes back into K. Okay. Then there are some side effect operators. J plus equals is the same as J equals J plus 5, and the same is true for all these things. Actually, that's a typo there, slash equals. And so most people do not use these formats. I just show them to you in case you ever see some code. I always prefer to write my increments and decrements and divisions out. It's not particularly faster that way. It's a syntax. This comes from C. All of these fancy bits come from the C language, and JavaScript and Java do the same thing. And so those two languages are represented here, and so that's why these operators are here. Comparison operators. All C-style languages, one of the trickiest things you got to realize is that the single equal sign is an assignment statement, and I like to think of that as changing. So the 10 is being stored into the J. To say, is J equal to 10? This is like a question mark. I wish this was like question equals. That would be like, is it equal to? But that's not what they do. They decided double equals was the one that was the question mark. And that's asking the question, is J equal to 10? And it returns a true or a false when it's evaluated. So J equals 10 is true. J not equals 17, that's exclamation equal. Again, I wish this was question mark equal, but that's going back to 1972. I had to catch them and say, no, don't make double equals, make question equal. Not equal, less than, greater than, less than or equal to. Now, there's a special operator, and you see this in Python in the is and is not operator. So the double equals is a comparison with type conversion. So it says, can the left side of the double equals, the J, be converted eventually to become equal to 0? And so in this particular case, J is false. So it is of type Boolean, but a false can be coerced into 0, so false is equal to 0 with some conversion. But then if we want to compare two things in terms of both their type and their value with no type, implicit type conversion, if I say is J triple equals 0, that says is J the same type as 0, which is a number, and has the same value. Well, J is a Boolean because it's true or false. And so this turns out to be false. So J is not triple equals, right? And J is not triple equals true. And so you have triple equals and not, it's like not equal equal, but I call it not triple equals. So there's a whole series of logical operators much like that return for you true and falses. And so we've got our greater than. So we've got double ampersand, which is and. So for the whole operation, for the whole expression to be true, both sides have to be true. So is k greater than 1 and j less than 10? And in this case, the answer is yes. Is k greater than 10? No. And is j greater than 10? So that's true, but this one's false. False and true become false. Or is k greater than 10 or j greater than 10? No, neither are true, so the result is false. And then there is a unary not operator that you can put in front. That's like saying k greater than 10, well that's false, but then if I apply a not to it, it becomes true. String concatenation is a little different than Python. It uses the plus operator, but it will convert things to string, right? So x equals 12 is a number, and I'm adding a number to a string, and it's like, I'll convert that into a string. And so that 12 becomes a string, and you end up with a string that's hello 12 people with 1, 2 characters. The number 12 is long gone at that point. So there is a conversion. Normally, if this were in Python, you'd say stir, parenthesis, to force it to a string. The plus is smart enough to automatically convert it. You can debate which of those things you prefer, and I can come down on either side of it. There is something to respect about Python that basically says if you want it to be a string, you as the programmer should say it. Languages that are sort of loosey-goosey, that do things to make it most convenient, like PHP and JavaScript, sometimes can get you into a trouble. And this is where you can always tell that nan. If you see nan in a user interface anywhere in the web, you're like, oh, somebody did a JavaScript calculation just like this, and something went wrong. Because that's what happens when additions go wrong. We'll see that in a second. So variable typing is a little confusing because we're using plus. Sometimes we're using it for concatenation. Sometimes we're using it for addition. So in this particular case, where we take the string 1, 2, 3 and add 10 to it, it sees that as a concatenation and gives us back a string. But if we say the string 1, 2, 3 times 1, then it converts that to an integer times 1, and that's 10. So it becomes 133, but that is a number. But what happens if we take something that's not even a number? Well, multiply it by 1. That is not a number. And then we add 10 to it, and it's still not a number. And this is not a number. And that's why you see nan on all these web pages, like %complete, nan. And that's because it was adding 1 to something like a fault, that wasn't a number and couldn't be converted into a number, like a string or something. And once you get something that's a nan, it's very, very, very sticky. But it doesn't blow up. It just keeps running and shows you nan in your user interface. So, if a string can't be converted because of mathematical operation, you get a nan. There is a function called isNan that gives you a true false, like is there a nan? Nan is a value. It's not the lack of a value. Something like null, or null would be a lack of a value, or empty in Python would be the lack of a value. Isnan is an actual value. It's just like a value that's the indication within a number that is, it's a number. If you divide by 2, you get another value that's not really a value. It's a special value called infinity. And if you like add 1 to infinity, you still get infinity. If you subtract 1 from infinity, you still get infinity. There's no amount of ones that you can subtract from infinity to get anything less than infinity, because it's like infinity. And there's a function called isInfinity that lets you know if the variable you're working with is infinity. So this seems kind of silly, but it turns out that in some ways JavaScript has one of the coolest number classes, because it uses this internal number format called IEEE 450 something, 455 or something. And it's actually a scientifically thought out, really good way to do number calculations. And so in some ways it does a better job of floating point numbers than some other programming languages that just kind of do unpredictable things at things like infinity and dividing by 0 or multiplying by an undefined or something. So you got to respect JavaScript, because they stuck to their guns on numeric calculations, and they're pure. They're the way computer science researchers suggest this is the way you do it, and that's exactly the way you do it. Seems a little weird. I make a little fun of it, but it's actually pretty cool. If you're in an untyped language and you're passed in like a variable and you want to know, is this a string, or is this an array, or is this an object, there is a unary function, which just takes one parameter, type of. That's typeof. That's the function. That's like multiplication or minus sign. Type of x, and that returns a string. So type of a number is the string number. If we say what is y, well, the string wy, it's a string, and you can ask for a variable that doesn't exist yet, and that will be undefined. And so you can say, is this variable defined yet? It's not defined yet. So this is where you're writing code and maybe passed a parameter and you don't know what it is, and you say, is it a string, is it an array, or whatever. So it's good to be able to, in an untyped environment, to take a variable that you might have been given by somebody else and check its type. So up next, we're going to talk about functions and arrays. So now we're going to talk about JavaScript functions and JavaScript arrays. So functions use the function keyword. Unlike Python, this would be like in the def. This would be like def in Python. And so we basically say, function, and then give the name of a function, and then the parameters to the function, and then you have a curly brace to start the function, and then end the function. Move this over here, and then you have return to return the resulting value, and that return defines the return value that's going to be used in some expression. So you're cruising along, you're in the middle of an expression, you encounter a function, it calls the function, runs the call, and then the return value is what is the residual that's placed in that plus. So whatever that value is, in this case it's going to add 4 and 5 and end up with 9 as the result, and prod equals 9. So the functions, other than that, are like most programming languages, except when it comes to global variables. And so most of the time when you're working with a function, every variable that you define inside the function is local to that function. And so if you use the same variable outside the function, now I'm doing this 2 lines away, but really often this function's inside of a library and it doesn't even know what variables are being used outside of it. And so by default, these 2 are the same. And that really, I'm not really familiar of a lot of other programming languages where the default is that that's kind of a global variable if you don't make it worse. It depends on whether this global variable is defined before or after too. In this case, I'm defining the global variable before, and I say nothing special about GL, and so it's global. And so I set it to 123, then I call this function, and it sets it to 456, and when we're come back from the function, it's 456. So that's kind of weird. It's this weird kind of super global by default, which is not the way we usually like to run functions. So what we do, and it's really weird, there's no other programming language that makes you say, don't be global. Most other programming languages, if they have a global capability, and not all of them do, they're like, this is the weird one that's global, and everything else is local. What you do is, if you don't say it's local, it's going to be global. So the var keyword basically says it's local. It's just, this is a variable and it's local. And so I can say, var GL equals 456. That means that that variable has no effect outside the function, i.e. the function lives in its own little silo, which is the way most functions usually work unless we explicitly bust out of the little silo. So in this case, if we do GL equals 123, then we call a function check, and we look at GL, even though inside a function there's a GL that's 456, not the same GL, and so we get 123 when it's all said and done. So that's really quite nice. But you do put a lot of vars in, and one of my biggest bugs in when I write JavaScript is to forget to put the var in. So I now just kind of been punished enough to know, always put the var in, so you get what you kind of expect as a default in most other programming languages, that all variables that are defined inside of a function are local unless you're very explicitly doing otherwise. JavaScript has arrays. They look a lot like Python lists. So here we have an array that's 3 strings. JavaScript has an associative structure, but it's not an associative array, and it's more like a dictionary, but it's not. It's an object. Objects can be many, many things, and we'll talk a bunch. We'll have a whole lecture on nothing but objects, but right now they kind of look like a dictionary. Key, value, pair, key, value, pair. Key is name, value is Chuck. Key is class, value is DJ Faree. And so that when you print that out, away you go. Now, you can say a sub 0, which gives you x, which is that first element, and you can say b sub quote name quote. You can do that. Another way to say that is b dot name. Those two syntaxes, and this confused the heck out of me when I was first learning JavaScript, those two syntaxes mean the same thing. They both are saying look up an attribute of the object b that's named name. And again, equivalent, they are the same thing, even though for every other language that you ever look at, you think those are very different creatures, but not so in JavaScript. And it has to do with the fact that b is an object. It is an object, and so objects are the associative structures, but they're even more powerful than associative arrays are in some languages, like directories. Linear arrays, you can make linear arrays. You can fill them up a couple different ways. You can either fill them up, we start and make an array and we can push some elements in. I don't like the name push. I like append better. That would be what we would say if we were in Python, if this were a list. But it works. Push kind of pushes onto the end. Normally push means push onto the beginning, but in computer science, push usually means push down, not append. So I think Python has JavaScript there where we say append in Python, we say push in JavaScript. Or we can just fill it up with the array, array sub 0 and array sub 1, and then we can fill up a nice linear array if we want. And remember, in JavaScript, arrays are arrays. They're not dictionaries. They are lists. In Python, Python has lists and dictionaries, and JavaScript has arrays and objects. There's other syntaxes for making arrays. You can say array and then just have a list of things that make up the array, and you get an array, or you just use the constant form, that's square brackets. And this looks exactly like how we would do it in Python, and so that works. So in that particular line, you can write Python in JavaScript if you so desire. Up next, we're going to talk about control structures. let's talk about control structures, logic, loops, and all that kind of stuff. So the first kind of control structure we're going to deal with is an if statement. And every language has an if statement. We have a whole bunch of logical operators that we just got done talking about. Equals, the double equals is the question mark. Triple equals is the same as and same type as. Not equals, the not, and then the and the or. Double ampersand is and the double vertical bar is or. And so triple equals and exclamation double equals. And curly braces are the way that we talk about the begin and end of the blocks that are affected by the if statement. So other than that, we say if parenthesis answer equals 42. This is kind of the question that we're going to ask, and that's going to lead to a true or a false. If it's true, of course, the first block is going to execute, and then there's an else, and then if that result is false, the question is false, then the else section is going to execute. And there can be more than one line in here. I'm just showing one line to keep it small on the screen. So when this code all runs, it basically comes in, answers 42, then this is true, answer equals 42 is true, it runs console log hello world, then skips the else clause and is all done. So the output of this is indeed hello world. There's multi-way ifs, and you can hang them together just like in with else ifs, just like in Python. And it does it in order. If this is false, if the first if is false, it checks the else if, and as soon as that's true, it runs that block of code and then hops out to the end. It doesn't check all of the if questions simultaneously. And you can optionally have an else clause so that if none of the else if clauses are true, then it just falls through and runs the code in the else block. You can have an indeterminate loop, a while loop that runs until something becomes true. It's a zero trip loop, which means that it runs a minimum of 0 times, which means it effectively functions the first time through like an if statement. So while fuel greater than 1, do this thing in the block, is really like an if fuel greater than run, if fuel is greater than 1, do this block. Although in this case, I've built myself an infinite loop because fuel starts out at 10, and I say, while fuel is greater than 1, console.log room, which means it's just going to do that forever. And that's because I didn't change the iteration variable, in this case fuel, and usually we construct these in a way that they terminate eventually. And so I've done a much better job in the second one where I set fuel to 10 and I say while fuel is greater than 1, and inside the loop I console log room, and then I subtract 1, and I go up and up and up and up, and then it's going to go, and then fuel will eventually get to 0, and then it will exit out the loop and finish. And so this here is an infinite loop, and this is a finite loop. While loops are always a little tricky because you've got to construct the iteration variable or make sure you know how to get out of the loop. The for loop is a counted loop, and it's going to run. And so there's 3 parts to it, and they're separated by semicolons. It looks really complex, but it's not. So you make an iteration variable. The first part up to the semicolon is the code that runs before the loop starts. So I'm going to set this variable count equals 1. The second part is like a while, and it's a top test 0 trip loop, and as long as count remains less than or equal to 6, then the body of loop is going to execute, and then each time at the bottom of the loop we're going to add 1. So this is going to go 1, 2, 3, 4, 5, 6. When it's equal to 6, it's going to run the 6th time, but then it's going to come up and be 7, but then the loop is not going to run. And so that's what's called a counted loop, where we have some variable that's just running through a set of numbers. In Python, we would use range to do this kind of a thing. Now, like in Python, we've got the break statement, and the break statement just says, I'm going to get out of this loop. So if this line executes, it looks at if there's more than one loop, it's the innermost loop, and it just basically escapes the loop and moves on to the line of code that follows the loop immediately. Just if it's done, get out. Don't execute another line. It doesn't run the rest of the iteration. It just skips out of the loop completely. Continue is another very useful thing. You can basically say, I want to give up on this iteration and go back up and do the next iteration. But the thing is, this increment usually is this third part of the for loop. If you say continue, that actually runs. So it actually continue goes and does the plus plus, and then it does the check, and then it either continues to run back here, or it jumps out if count is now greater than 10. And so continue works pretty much the same in loops in JavaScript as it does in Python. So you can also loop through objects. And so here's an object that has three attributes: golf, tennis, and ping. And I can say for ball and balls, and then that means that this iteration variable is going to walk through the keys or the attributes. So it's going to be golf, ping, and tennis. And then I can use the lookup syntax to look up balls sub golf, balls sub tennis, and balls sub ping, and then print all those things out. So that's what's called a definite loop. That's looping through an object that we're going to see. Now, when you're looping through an array, which is a linear list, you actually use a counted loop, not a definite loop. But objects, which are like dictionaries, which are like associative arrays, we use definite loops to loop through them. So that is a quick romp through JavaScript. Not so much to get to the point where you can write a bunch of JavaScript, but so you can read it, and then when you get a syntax error, hopefully you can fix it. Hello and welcome to our lecture on object-oriented programming in JavaScript. I teach object-oriented programming in Python, in PHP, and in JavaScript. And I use the same slides over and over and over again, and that's because object-oriented concepts are the same. So if you've taken other classes from me, you've seen some of these slides. They're adapted a little bit for JavaScript because JavaScript's object-oriented pattern is particularly awesome, right? But there's this concept of a class, which is like a template. There's a concept of code and data in a class. Whether you call the code method or message is up to you, whether you call the data attributes or fields. And then an object is an instance of the class. And so the cookie cutter is the shape, that's the class, and the cookie itself that can be specialized, and it's an instance. Millions of cookies come from one cookie cutter, and that's object-oriented. So the key is the craft of it is building the cookie cutter so that it makes awesome cookies. So the class, like I said, is the template. It's a blueprint. It's not the actual thing, but it is the precise instructions on how to make the thing. An instance is once you make the cookie, you can have different frosting on it. You can have all kinds of other things. You can make subclasses, which is what we do for inheritance, which makes specialized versions of the class. Now, the methods are the code. So in classic programming, we think of like code and data structures, algorithms and data structures. Data structures are the shape of data, and algorithms are the shape of the code, the way the code is made to work. The methods are the algorithms that make up the code part of every object. Every object has code and data, and often the code works on the data that's inside the object. Some object-oriented sort of schools of thought use method, and some use message. The more purist folks tend to use messages, like you're sending a message, here's the object, not the class, you're sending a message to the object. I tend to use method because method is a bit of code that lives in there, and that's just because I think of things from like a Fortran or C, very procedural way of thinking. So objects in JavaScript are a little different, and if you've seen me talk about objects in Python or objects in PHP or even objects in Java, which I taught a long time ago, or C++, they're very different. And the key thing is it certainly is a store and reuse pattern. It is a mechanism to create data and code and put it into one kind of reusable thing. But the key thing is that the function keyword is actually, in a sense, an executable statement. And you can take and call and use the function keyword, and the function is, in a sense, calling a function that causes code to come back to you. So you can have the function create code and then assign it into the variable. These are called first-class functions, and it has to do with the fact that in first-class functions you have this symmetry between code and data. The code is just data, and of all of the modern programming languages, Lisp really was the original code data kind of duality. JavaScript is very, very, very much throwback to the Lisp tradition of data and code look the same way or can be treated the same way. You can have X as a variable and you can assign it to be 42, you can have it be a string, or you can have it be a function that adds two numbers together. And it's just X. And that is kind of elegant. So that's called first-class functions, in that functions themselves are the code. The code in systems is manipulable as data. Copy around, use it, reuse it, etc. So up next, we're going to take a look at how we put together a sample class in JavaScript. So now I want to show you a little bit about how we build classes in JavaScript, so how we build our own classes and how classes work internally. You may have noticed that the coffee cup that I'm using during this JavaScript lecture has code on it, and the code is somewhat JavaScript-y. I think it's JavaScript. It's C, Java. I think this would be C or JavaScript or Java, because again, these are all related languages. So let's take a look at a sample class here. And so the first thing to notice is that it uses function as the keyword to define a class. Now, you might see what's called ES6 classes, and it's a like syntactic sugar that layers on top of this that makes the syntax look more like the other languages. And so this is kind of like vanilla, the underlying actually how they work. And so I guess I'm glad that they've made syntax that looks like everything else, but it really belies the elegance of the original way it works. The syntax doesn't change how it works. This is how it really works. And the things that's super excellent about this is that it uses the function keyword. There's not a different keyword, okay? Every other programming language, pretty much when they go into an object, they use a different than they're in their procedural. So a class is a specialized function that, as a side effect of its execution, returns code and data. Okay? Now, we'll see that we invoke it a little bit differently. So let's start and take a look at what we got here. We got this function party animal, right? So party animal is the name of the class, but it's code. And again, we have a curly brace to start it. And the thing that's different is there's this notion of this. So we make sort of an empty vessel that is going to be the object that we're going to use this class to populate. And then by running the code, we're actually populating that empty vessel. So this .x is going to create a member variable called x inside this, which is the empty vessel object that we're creating, and then we're going to fill up, okay? And then we have this.party. This.party is also a piece of data in the this object that we're about to create. And you'll notice that we're saying equals and then function. But this one is a little different. You'll notice the function is unnamed. It is what we call an anonymous function because it doesn't have a name. So the function's name is actually called party, but it just happens to be called party because we're storing the function's code in an instance variable called party. But that's how we're going to call it. So in the party variable, we have the code that is those two lines. And then within that method, now I'd call party a method to use the terminology. Within the party method, this is the instance that we're talking about. In Python, we use self for this, right? And different languages have this concept of the current object that we're part of. This.x is referencing, remember how we talked about global and local inside of functions? Well, this x is actually outside of the function. So this is an advantage. The this.x is defined inside the function, and because this is defined before the function definition, it sees that, right? And so we're going to add 1 to that member variable, and then we're going to put out a console log message, and that's our entire object. It's got one attribute called x and one method called party. Okay? So we could just call this function party animal, but that's not what we do. We have a new keyword called new. And it says, look, don't just run this code. Create an empty object and then use the party animal code to sort of fill out that object with a bit of code and a bit of data. And so that says run all this, but instead of just running it, give me back the thing that eventually it produces. It's as if there's like a return statement at the bottom of this thing, at the bottom of party animal function. And then give me back the object. And now I have an object, and it's got an X in it, and it's got a party in it. Then AN is where I store that object. So AN is my first instance of a party animal object. But now I can talk to AN.party and call it again and again. So I call AN.party 3 times. So I call the method party. Okay? So that is the basic mechanism. And so if we were to somewhat trace through this part here, the function just is a template, that it's remembering the template and naming it party animal. And at the point where we have an equals new party animal, JavaScript constructs this object, and it's got two things in it. It's got an X in it, and it's got a party in it. X is data, and party is code. And then that's what it looks like, but it's got, well, actually no, the construction, got to change here. The construction also put a 0 into this .x. And so it, as a part of the creation, it ran all this code to construct party animal, and this got set to 0. So when we're at this next line of code, before we call an.party for the first time, an.x has got a 0 in it. Then we call an.party, and it runs the code. an.party, this an is an alias for this. And so in a sense, when it says this.x, it really is an.x. Now we'll see in a second how when we do multiple instances, how that works. So it runs the code, and then it adds this to be 1, and then it prints out the first line, and then it does it again, and then it becomes 2, and it prints out the second line, and it does it again, prints out 3, makes it 3, and prints out the third line. So that's how this code works. This is the constructing, or creation, or taking the little cookie cutter and poof, making a cookie out of cookie dough. You got a bunch of cookie dough. That's like a little object that doesn't exist. It's got no form, and then we take the template and we make the thing. So I mentioned the word constructor because there is this moment where it's actually building the object and filling it up with all the little pieces. So objects are created, used by us, and then discarded. And there is this concept of a bit of code called the constructor in object-oriented theory that says, look, I'm going to start an empty object and then I'm going to fill it with stuff. And the constructor is the sort of filling it up so it's ready to do its job once you're done constructing it. Destructors are a common concept, and we talked about those when we talked about object-oriented in Python. You don't get to get a hold of the destructor inside of JavaScript. That's something that they just don't let you do. And I think it philosophically has to do with the idea that you're in a web page, you're not going to be there for very long, and that's really the earliest of days, right? These days with things like Vue and React, some of these JavaScript pages last a very long time, and maybe it'd be useful to have destructors in there, but JavaScript didn't have them in the beginning. Okay, so the constructor is, in a sense, the moment where this new is triggering the constructor. And what it basically does is creates basically a blank object that has nothing in it, and then runs the code inside a function party animal to give some form to that object, right? And so this right here is the constructor, right? And so I just put a console.log so you can kind of see where that happens. It says I'm in the constructor, and then this thing works the exact same way. It's just I've kind of instrumented the moment that we're in the constructor. Okay? And the purpose of the constructor in object orientation is to set the initial conditions of the object so that the object is ready to be used. And like setting x to 0, setting x to 0 is apparently for this object a necessary condition. So once we have a template, cookie cutter, we have a class, party animals are class, then we can make many different objects. And then those objects have each independent data. That's the key to this, right? And we call this having multiple instances or multiple objects that implement a particular class. So here we go. Here's our same old party animal that we've been talking about all along. The only difference now is we actually give a parameter here. And so one of the things that this is going to do is, as part of its construction, it is going to copy that first parameter into one of the instance variables. So we're going to have two instance variables, this.x and this.name. And we're going to copy whatever that is. Now, where does that come from? Well, it comes from the moment of construction when we're saying, make me a new party animal. Oh, and here's a constructor parameter. So that Sally goes in as nam. So this.name equals Sally. This.x equals 0, and then this.party is exactly the same way. And so when we run this, it comes in, it constructs Sally, setting that, and it says built Sally, that's that nam, and then we call Sally s.party. So this is the actual object is in the variable s, we call s.party, and this.nam is Sally, and it's equal to 1. And then we make a new one. Going to make a new one, but this one's be called Jim. So we make a second variable, a second instance variable. It's going to have a second copy of X and a nam and actually a copy of party, right? And so then it'll say built Jim, and then we say j.party, and then we set Jim to 1, and then s.party, and it sets Sally to 2. And so now the j variable and the s variable are completely independent variables. And so halfway through, so when we're down to here, we've got this object, s.party, well, x starts out at 0, and the name here is Sally, right? And then s.party comes and runs in here and prints out Sally equals 1, right? And then comes back, and then we're going to create a second one. So we created a second one, and that'll be in the name j, in the variable j, right? So we've created one. Oops. We've created one. Create Jim. Out comes built Jim. And then and then this is 0, this is Sally, this is 1, this is 0, this is Jim, right? And it says Jim equals 1. And then we're going to call s.party here at the very end, and so it's going to run this party code again, except now this is an alias of s. So you can see how when we call j.party, this is an alias of j, and we call s.party, this is an alias of s. These are instance. So s is one instance, and j is another instance of it. And so that's how we take one class and make multiple instances, and each instance has their own independent copy of the variables. So that's a real quick introduction, mostly to get syntax. I'm not going to ask you to write a bunch of objects, but we're going to use a ton of them. And when you start learning about jQuery and document object model and all that stuff, this dot syntax and the methods and the member variables, the attributes, away you go. So you got to know all this stuff. So class is a template, a method or message is the code that's inside of objects and classes, and then attributes is the data inside objects and classes, and then constructor is the code that runs as one of these things is created. So that's a real quick romp through object-oriented JavaScript. It's actually in some ways one of the I debate with myself whether I think that the Python or the JavaScript object-oriented pattern is more prettier. I mean, there's other ones that aren't as pretty as these two. So in Python and JavaScript, I think we're fortunate to have two very mature and very advanced thinking in how to really build beautiful object-oriented systems.
Hello and welcome to another code walkthrough for Django for Everybody. In this we're going to walk through the how to handle pictures, and in our DJ free samples I'm going to walk through the code. So first let's walk through just how it basically works. It's a CRUD application. This is CRUD, and now we have this browse thing to upload a file. And so we'll upload that file, and then when we look at it, we're going to see it. If I click on the picture, I get kind of this overlay view. That's all JavaScript, and then I hide it, and I can upload it. I can edit and delete it. So let me kind of walk through how this works. So first off, let's take a look at urls.py. There's nothing particularly special. The whole pattern is kind of the same. I'll come back to this particular URL, the actual picture, the thing that in a sense serves the picture. So if I could open this, view the image in a new tab, well, it's this URL that's actually serving the image. This image is stored in the database, and so we'll come back to that particular one. It's the stream file view. Okay, so let's go back to all pics, and let's start taking a look first. Let's go at the model first, because this is where everything starts. Sure, let's go put the model here, put the views there, and the forms there. Okay, so let's start the model. We'll start from the back forwards. So if we were to go look at the admin, I think I've got the admin hidden in this particular one. Let's take a look at admin.py. Yeah, this is one of the things. Let me show you how the admin works. I hope I got admin going. Probably don't have my admin account. Oh, there we are. We have admin. So if I'm to take a look at the pics, so it turned out that I didn't want either of these two things to show up, because it turned out it made it difficult because I couldn't update things. So you won't see picture or content type here in admin, and I do that by excluding this. And instead of doing the shortcut, I am going to register for the model pic this particular class, and it allows me to have this class-wide variable called exclude so that I don't show those things. And so that's just a little trick on admin, so that when you see it, when they're in the database, they're just not there, because you can't, because the admin interface is not smart enough to update these pictures the way I want to update them. So I'm going to hide that. So in the model, we've got a binary field, which is like a blob if you're into databases, and I'm allowing it to be null and blank and editable. And then there is this thing called the content type. And the content type is, I'm going to open this in a new window, copy image location. So if I were to do a view developer console network, one of the things when you're serving images is that you've got to set the MIME type. So this is a GET request, and it sent a bunch of data. But if I look at the headers here, the response header includes this header called the content type. Oh no, that was the icon. What am I doing? Persist logs. I'll clear this. It's not the icon. That was the icon, but let me refresh this. And so this is the actual PNG, and then the icon comes as well. Of course, the icon's that little picture, but the content type is image/PNG, and that's really important. When you're uploading the file, you get to have it, and then you have to send it back out. Otherwise, the browser will not know how to properly format this. So that is what is here, right? That's the content type. It's just a string field. The content type is just a string, but it's very important to track it. So when I am in an ad, when I upload the file and I pick it, it's actually communicated to me as part of the uploaded data, but I got to remember it. I got to, actual pixels go in here, and the content type goes in its own character field. The pixel goes into the pixels of the picture, the actual colors and stuff go into this binary field. And I'm going to use the owner. So we're going to have this, we did this before, we have an owner, and that's just going to be automatically created when there's a owners.py, there's a owners.py. So there's owners.py, and I mean the owner.py from the previous thing, and that gets all taken care of in the views. So all we got, it's pretty much a standard thing, except we've got these two things, and those are hidden from the admin. So now let's take a look at the views. And so we're going to use the owner views again, and those are automatically handling all of the detail of setting the owner field, and there is just not a single line of code in here that has anything to do with setting the owner field. I have this owner field in my model, and then I just extend for all of my other views, I extend that, okay? So I have an owner list view, an owner detail view, and you'll notice those do not require login. I'm going to specify the template name. I'm getting a little tired of just remembering. I don't necessarily like their naming conventions, and so I'm going to have my own template names here. And pick create view. This one you're going to make one. Okay, and we're going to have a get request, just like going back because I can't quite make this one complete, and my post request. And so the post request. Yeah, I'm gonna. So I'm just this. I might have been able to extend something or put inside, but I'm just going to do all the work. You'll notice I'll walk through this. This will be a good review of that. So let's just look at the. Let's look at the pick create view next. So let's take a look at forms.html. So. Well, now let's look at forms.py. So the create form. So if you think about it, if you recall, right, there is the views in the middle, views, and then the thing that talks to the browser that really controls our relationship with the browser is the form, and the thing that controls our relationship with the database is the model, right? So the view is interacting with the form to get what it needs to do, and then it kind of transports it to the model. So that would be kind of like a controller function if we're thinking a model view controller. This would be, but that's okay. So the form is what determines all of what's going on this screen, and then the model. Yeah. Oh yeah, that looks really not good. The model is what is going on back here, and so you can think of the view as like manipulating both the form. Escape, both the form and the model. And so it's interacting with them. And so you'll see when it's doing things in the beginning, like clear, escape, boop, boop. Okay, so you'll see that in the view, when it's doing its work, it's working with the form, and then eventually it's working with the model toward the end. Okay, and so to some degree, this post request is to get data from the form and handle everything when it's doing it. So let's avoid to some degree the hardest bits. We'll come back to that in a second. So let's go and hit cancel and then add a pick. Add a pick basically runs this get request. So we're going to grab the form. It's the create form, and there's a little bit of work in here. There's the create form. And we're going to jack into, just object-oriented ways, we're going to jack into the clean, we're going to jack into the save. But for now, all it's doing is this bit right here that you've been using for a while. And so we're going to tell it what, we're going to make a picture form. And so here's a thing. So there is a file field. And so we're asking the form to include a file field. Okay? And so that's what puts out this file to upload less than or equal to 10 megabytes. We've got a little bit of code to both have a numeric limit of the size, max upload limit, that's just a class-wide variable, and then the max upload limit text, which is that in text, and that little file to upload less than or equal to 2 megabytes, that's because I'm doing this in the form. So I got a little bit of logic in the form, and it is a model form, which means that it takes its input from it. I don't have to put these things in there, but I do have to tell it which things I actually want to do. And so I want the title and the text. I don't want the owner, and created, add, and update are kind of automatically. So that's why I've got the fact that inherit from the pick model, which is this model, inherit from the pick model, and include title, text, and picture. Now, title and text come from the model, and picture comes from right here. So we're not, if Django were our friend, it would understand this would be a file field, but it's not. And so we have to actually manipulate it and convert it. It's not hard, but in between the view, the form and the model, we got to do a bit of work, and we do it here in forms.py. Okay, so meta. Okay, so this part here in the top is all that is affected to create this screen, right? So that's what the get is doing. So if we look at the get, it makes a form, and then it renders it to self-template, which is pics.form.html. And here we go. It's pretty straightforward now. We're just going to load our crispy form tag, extend our base bootstrap, put out the CSRF token, pretty up the form in crispy, and that's sort of everything from title into file upload. And then we have a submit button and a cancel button. So one of the things that we're going to do is we are going to add some jQuery. And that is we're going to connect into this form. And when the submit button is pressed, we're going to run this JavaScript code. So that this line right here, upload form submit function, that makes it so that whenever this submit button here is pressed on this form, this jQuery is going to run. And so we will do a web developer. Well, it's not going to do us much good because actually we can. So I'll show you how that works. So what we're going to do here is this is a bit of code. I got this off Stack Overflow right there. And what I'm going to do basically is I'm going to read whether or not this file is greater than or equal to 2 megabytes. So if it's greater than 2 megabytes, I'm going to stop and complain with an alert statement. So this is JavaScript. And returning false here says I'm not going to upload it. So let me create one with some stuff and let me browse. Let me find a really large file. Okay, so now I'm going to do a web developer JavaScript console. Oh, and by the way, let me do a view source on this so you can kind of see that you can see all the stuff that came from base bootstrap, and you can see there's the CSRF token, there's the file input types, and then here's submit, and then here's the JavaScript at the bottom. And this JavaScript is running code out of jQuery, and we'll talk about jQuery right now. We'll just look at it as JavaScript, and we happen to be using the jQuery library. Okay, so now what I'm going to do is I'm going to press submit, and I'm going to watch this console. I'm going to press the submit button, and code is going to run, and you're going to see the JavaScript run, and it's not going to be happy with this file, Sakai, Ladies of Sakai, because it's too big, I think. Yeah, so there you go. Look, it said checking file size, and it complained that this Ladies of Sakai camp type must be less than 2 megabytes, which is exactly what I wanted. And so that I enforced that rule right here. Okay. Now it turns out that I got to also enforce it in the server because somebody could easily just override that and force it to be uploaded. But you see that the JavaScript is running in this browser, and it's kind of protecting it. Other than that, this looks pretty much like a standard CRUD thing, except very importantly, if you're uploading files, you've got to say enc type equals multipart/form data, and that has to do with the format that the data is sent. If you just have like a few text fields, then you don't need this, but if you have longer things like files, you need that. And so that is how we get through the GET request. Okay? So now, let me pick a better file. Pong, my favorite. Where's my Pong? Oh, that's dangerous. One of my earliest, I don't know. I got so many little files. Apple iPhone, Sakai JPEG, what I don't know, whatever. So this one's nice, less than 2, and I'm going to hit the post. So I'm going to hit the submit. Now the post is going to come through, and it's going to run this code right here. And this is probably the trickiest part of this code. So if you recall, we can construct a create form and get it back, and we pull the data request.post. Now it turns out that these little attached files, like Apple iPhone Sakai JPEG, comes in request.files, and or none just in case it's not there. Okay, and so what happens is this is where we're going to do some of our work. We're going to actually pull data from this request.files. And so we're going to jack into the clean. So clean is one of the life cycles of a model form, meaning once the data comes in, it's going to ask to be cleaned. So what we do is we call the super class, the model form class, and do the clean there. It doesn't know anything about picture because we're the one that added that, okay? But then we get the data in cleaned data, and it's a dictionary at that point, and so I can get the picture. So remember that the form is the part that's coming in from the browser, right? And then I can make the picture. I can get it from there. If I got no picture, I don't need to do anything special, right? If I am checking to see if the amount of data that I got from that upload is greater than that upload limit. It's good. So this is mostly here to check to make sure I'm cleaning the data. I'm not actually saving it, but I am grabbing the picture from the form and I'm checking to see if it's greater than 2 megabytes. And then I'm going to add, this is what you do in clean. Clean is just to say a nasty message. Now in this case, the nasty message I showed you before came from JavaScript, but if you somehow tricked my JavaScript and sent it, this clean would catch it. And so if I'm in my view here, clean is happening right now. Form is valid happens afterwards. So as a side effect of clean, you're saying, is the form valid? And if there was an error from this, or if there was an error like my title was too short, right? Then, boop, it would come back and say title's greater than 2 characters. Oh, we love crispy forms. Look how pretty errors are in crispy forms. That is running this little bit of code right here. If the form is not valid, and it could have been, and in that particular case, the super got upset, right? Because this min length validator triggered, and so the super got upset and set form was not valid. Now mine looked good, right? So, but now the picture's gone, so I can make a slightly longer title here and browse a completely. I don't know what I'm doing. These are really old pictures of mine. So now it's going to pass. It's going to pass. This is going to pass, and I'm going to grab this, and I'm going to do my own check. That's sort of a double check on this less than 2 megabytes, because even though the client protects you, and that's the more user friendly, because this is catching it after the upload happened, and that might be long. 2 megabytes doesn't take that long. But now it's going to come, and it's going to pass this and skip, and then it's going to come here. Boop, and it worked. So here's what's happening. So you've got the form. The form has took all that data, including the file, right? And cleaned it all up. And I'm going to call form.save, commit equals false. And then I'm going to set the owner field because I'm not extending owner view here. So I got to set that owner view because I'm going to ultimately override both this post and the get. And I wasn't going to get much help out of owner at that point. And then I'm going to save the model. So form.save gives me back a model. If I don't say commit equals false, it actually does the pic.save also. So if you save the form without commit equals false means don't store it in the database. Okay? So let's take a look at what's going on here in form.save. So I have also overridden form.save, and I'm just behaving commit equals true as a default. But when I say commit equals false, then commit will be false. And so I have got to call the super, right? Actually, this is really not right. Oh no, actually, no matter what the commit is, this is the end user's wish for commit. I am going to do a super, and I'm going to run a save with commit false. No matter what this person wants it to be commit true or not, I'm going to run commit false. Then what I've got to do is I've got to grab the picture from the form. I'm in a form, and I check to see if this is an in-memory uploaded file. And there's all kind of cool magic that's happening right here. It's got this it's in memory, it's got this thing, it's an object, it's really nice. And then what I say is give me all the data, the byte array, which reads all of the pixels of the file. And then f.content type is that image/png. And I then need to put that in the instance, which is the model. I've got to add to it the byte array of the text and the content type. I've got to store both of those things, and now I'm talking to the database. The picture and the content type are being set as part of the save. Then what I do is, if commit is true, now I'm trying to mimic the save behavior. Now I'm only using this one way, right, with commit equals false, but someone might leave this out and call my form. I'm supposed to actually save the model if commit is true, but in this case commit will be false, so I'm just going to return the instance. At this point I have an object model, and in that object model all these two fields are exactly the way they want to be, and the only thing I've got to do is set the owner field, which I'm doing right there, and then I'm storing it in the database, and then I redirect. And that's how it works. It's pretty cool. You got to kind of get your object-oriented Zen thing going, and pretty awesome. So I'll just go through the update view because it's not that different than the create view. So it looks the same on the get. We're going to go grab the old copy out of the database, and then we're going to make a form and inherit all the old data. Now in this one, it's not going to put the picture out there. It'll just put out a new one. So if I'm in the edit right here, it's not going to put the picture here, but it'll let me put a new picture here because that's in the form. But all the old data is sitting right here. And then that renders the update form, and then I make my changes, blah, 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 blah. Actually, blah, 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 right? Blah, blah, blah. And then when I post it, it's going to do this create form, and the difference is it's going to do a get object or 404 so that it pulls that old data from the database. And then it does the validation automatically. It calls this clean to do that validation, and then we save it, etc. And so that's how it actually updates all of this stuff. So the only thing left to take a look at is the detail page. And so some of these things we don't have detail pages and some we do. So let's take a look at this one, right? So this detail page looks just about like every detail page. Let's go take a look at the view. And so it's pretty good. I mean, we're using the same code that we've used for everything, and we're using owner detail view. We're telling it what model to use, and I'm going to use pix detail. And most of this, like again, humanizes to make times and dates look better. I'll get back to that CSS in a bit. Here you have, we'll come back to this too in a second. I'm just showing you the parts that are like the way you've been doing it. It's got the buttons for the update. This is part of the owner code, right? If the owner is the user, we're going to write a pencil and a trash little icon, and then print out the title, and then the text, and then some all, right? Some all stuff. Okay? So that's what's familiar. Let's now talk about what's different. So let's first talk about the HTML that generates this little picture. So if I do an inspect element, we'll see that what we've got here is image style, float right, max width, that's some CSS. But the source here is pix pick picture 3. And so if you look, what I'm doing here is I'm going to the pix pick picture view and then the pick ID. And that pick ID is just the pick that came in. And if we go back to URLs now, that's this one. And it goes into stream, views stream file, and it passes in, an integer number as the variable pk. So let's go take a look at that. So that's this one. And you'll notice that this is not a class-based one. It's an old school one, mostly because, hey, I'm just going to do get. With class-based ones, we can do def get and def post. But this one, I'm just going to do an old school thing. Passes in the request, and the first parameter, which of course is that number 3, that's the primary key of the image that we're trying to see. Right? So I'm going to do a get object or 404, and of type pick, and I'm going to look it up by its primary key, which is that 3, and now I have it. And so I'm going to send an HTTP response, but this is not a text response, nor is it HTML response. This is where that content type, going back to the model, remember this is the MIME type, that image/PNG. And so, oops, come back. So as part of the response, so now if I can get this guy to open in a new, can I make that guy open? Come on, open a new page. Can I do that? Come on, open in a new page. View image, is that gonna work? Well, okay, I guess it sort of worked. I want to view image in new, view image in, okay, there we go. That's what I wanted. I'll just go back and put this in by itself. So now I can see that this is the URL that generates the picture. Now the picture is sitting in my database, right? But if I do view web developer and go into network and clear the network and make sure I've got, oh, it's already cleared. Persist logs and disable cache. Now if I hit refresh, you're going to see that it's coming back and the response content type is image-png. So to set this, and that's essential so that when the browser is seeing the pixels, it knows that this is a PNG, not a JPEG or a GIF or an MPG or a PDF or whatever. So this content type is something that we stored. We got it when we were doing the post, and we pulled it in, we took all that stuff, and if you look at forms.py, it was grabbing it here in the save method, and we got it from the form, and then we stored it in the database, and now we got it back from the database. And so we're just saying the content type, which is a header, is pic.content type. That's a string. And then we also have to tell it how long it is, but pic.picture is the actual pixels that are the picture, and you have to tell it how long it is. So if you look at content length, right there, 470,152, yeah, 470,152. So that's content length. We knew that from the database. And then we actually write the pixels. And the place you see this is when you click on response. Now it's basically showing you, yeah, that's a picture. But if you really looked at it, it's just, you know, bits and bytes and complete gibberish. And so that's what it takes to send that stream out. And so that's what makes it so that when I have an image tag, when I have this image tag, I can source, but I'm actually feeding that picture. Okay? So that's how the picture gets there, but then I'm going to show you how, when I click on this picture, I get this overlay, and then when I click on the overlay, it goes away. Now there's all kind of fancy things, and Bootstrap has modals. I did this with the simplest and crudest of CSS and JavaScript tricks. Okay, so let's take a look at how I did that. At that point, now we're in JavaScript. So first thing I've got is a CSS, and it's this overlay position fixed, and you'll see that I have a div tag that has the picture in it, and it's got a whole bunch of CSS in it. The width is 90%, the margin top, the border is 3 pixel with a solid black. So you'll see this. It's 90% of the width, it's got a 3 pixel margin. It's the margin top is 50 pixels, so there's 50 pixels here. And so that picture is there, but because this class equals overlay, all this other stuff is there as well. So that's not the picture, that's the rest of it. So you can see that this is fixed, which means it overlaps. This div and the rest of the page, this div right here and the rest of the page are like 2 layers. Z-index is 10, puts it on top. 100% width, 100% height. Display none means it starts out hidden, and then I've got kind of this little gray. You see this little gray bit? Right? And then the image has this style, the width 90%, margin top, 50 pixels. That's giving me the border and the margin and making it 90% wide. Okay? Well, let me get rid of it or hit refresh. So it's not there. It's not there. But if I do a view page source, Buddha, 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 view page source, it is there. It is there. It's just hidden, right? It's hidden because I told it to be hidden here. So it starts out hidden. So how does it unhide? Well, if I look, I've got this image here. This is the actual image. That's this image that's really showing on the page. And I've got an on-click, bit of JavaScript. And so on-click. So what I'm doing is I got an on-click there, and then I say document.getElementById overlay, which is looking for whatever tag has ID equals overlay, and then I'm changing its display from hidden to block. And so when that on click happens, when I click on goodbye. So when I click on this image, I've got an on click event anywhere in this image that is going to show this other div. So this other div, poof, pops out. Now what I've got is an on click method on that div, so that I can click anywhere in here, including the picture or the background, because that's part of the overlay. The overlay is the entire div in the background. So I can click anywhere, click, and then that triggers this document get element ID style display none. So it's still there, it's hidden, so I can bring it up, I can hide it. I can bring it up, I can hide it. I can bring it up, I can hide it. And I tried to make this one as simple as possible. There are prettier ways, and people put little X up here and it hides it. They make a whole modal, they use Bootstrap, they use all kinds of clever things. This is like the least clever way to make a full screen, semi-full screen pop-up of an image using a bit of JavaScript here and a bit of JavaScript here, and then some just slightly clever CSS. And I'm sure I found most of this on Stack Overflow somewhere. So I hope that you found this particular walkthrough of how to add images to a CRUD application useful. So hope you found it useful. Cheers. Hello and welcome to another code walkthrough on Django for everybody. We're going to walk through some sample code today. It's the code that really starts using the many-to-many work a bit. And it's our forums code, okay? So let's just walk through how it works. The idea, I've got two users logged in here, just two different users. This is also going to demonstrate the owner pattern again. So let's add a forum. Forum 1, hello. So this is just CRUD at this point. And so this looks like most of the CRUD things that we've built. I won't go through edit and the delete because the interesting part is here in the detail page. And so I can put a comment in. This is Firefox comment. So I got one user logged in on Firefox, submit. And then I will refresh here in the other one and I see forum 1. So, well, let me just make a comment. And this is Safari. So you can see that this is the Firefox comment and the Safari comment. And now if I hit refresh here in forum 3, you can see the Safari comment and the Firefox comment, which I didn't even get my typographical error done right. Well, the key is now you see the delete button is appropriate. So the comments are owned. And what's even more important is, sorry about that typo, is there's multiple of them. Right, so now if I just hit refresh here, you can see that and see these things happening. And so for one forum, each user can have many comments, right? And so this has to be a many-to-many relationship. And then if I go back to all forums, well, this guy sees the edit and the delete, and then this one does not see the edit and the delete. So you get the idea that that's pretty much what it does. So let's take a look at the code here. There is not too much tricky in the urls.py. Most of the urls.py is like all CRUD things we've built. But the comment is yet another table, because there's really two tables here. There's the forum table and the comment table. And so we've done stuff like this where we've got two tables involved. There's actually three tables involved, but one of them is the user. So we'll come back to this a little bit. There's not too much outrageous or new in that. But we do have two models. Oops, let's get that back on. The first model is the forum model. And this is, other than this new many-to-many field, this is really very straightforward. It looks like almost everything we've been doing that's CRUD. It's got some fields and it's got an owner key. And so again, there is a table out there. There is a model out there, the user model that's out there, okay? And we're in effect drawing a picture. This is a one-to-many, so that, oops, let's try this. Is the pen working? Pen, come on, pen. Hang on. There we go. So owner is a one-to-many relationship. That is that there is a user table, and then there is a forum table, and each user can have many forums, right? So each user can have many forums. So that is our table. Now, what's going to happen is, the interesting part is here, but let's first talk about the comment table. So the comment table is down here, and the comment table has one user can have many comments, and one forum can have many comments as well. And so because, in a sense, there is a, let me change color here. Come on, change color. Let's go violet. Because there is a many-to-many relationship between users and forums with a little bit of comment data sitting right there in the middle, we have to model it as, that has to be modeled as a completely separate table, right? So there's only two tables here, but really there's three tables here because the user table is participating in both of these models. And so we'll come back to the many-to-many field. So this is the comment, and like connection tables or junction tables or join tables, it has two foreign keys. It's the most important thing. It's the keys in each direction. I guess I shouldn't have changed that, right? So come on, give me, can I draw? Yeah. Right, so we got the user table, we got the comment table, and we got the forum table. So forums can have many comments, users can have many comments. These are forum, and so a user can have many forums. So this side of it is a foreign key, and this is a foreign key as well, right? Coming out of the comment table, there are two foreign keys, and look at that. There's a forum key aimed at the forum model, and then a foreign key coming out of the comment to the user model. Now again, we've talked about in the lectures, we've talked about modeling data at the connection. So the text that we're getting is the text that we're getting at the modeling point is this text right here. It is the actual comment itself. And you could make a different table for it, but it's just as easy to model it right in the middle of the junction field. Okay? And so that's pretty much it. And we have to, in the in the forums field, we are basically saying, look, we're going all the way through the comment model, and we're coming out the other end in the user model. This related name is really, really important, and that's basically a name. Let me draw my picture again. I should have probably just drawn this picture and kept it. The user table, the forum table, and the comment table. Forum has many comments. User has many comments, right? And so, in a sense, what we're seeing here is this basically says that there is a relationship between forums and users, and it is in the comments table. The table that it goes through is the comments table. That's what the through means. And then the related name equals forum comments is actually you're installing in the user object a method, an attribute, something in this user model that says forum comments. So we're actually extending the user model. If we were looking at the user, we could say, hey, what are the forum comments for this user? And that would give us it would come over here and it would give us a list of all the forums. Actually, no, sorry. It would come over here and give us a list of all the comments. But this related name is the name of this attribute. And you don't necessarily need all the time to be able to do this. But the problem is after a while, when you're plugging so many things into the user model, you can end up with you can end up with name conflicts. And so it's good to name this thing even though we might not use it. So I hope that helps. So this is a pretty straightforward thing, other than the fact that the user model is our third table, and we're using it in both places. So there is that. So the forms. So the only place I'm using a form in here is this comment form. So I just made it, and the reason that I made a comment form is that I wanted to be able to make it look pretty. I wanted to be able to use crispy. And so instead of just making this comment form on the detail page out of HTML, I just made a form so I could use crispy in the detail page. Okay, so that's the forms. The views are pretty straightforward. The create, the delete, we'll come back to comment create and comment delete. They're not all that tricky either. Probably the trickiest thing going on in here is the forum detail view. And we're extending owner detail view, and we're gonna have the template name and the model and all that stuff. And we're not gonna post, actually. You'll see in a second. We're not gonna post back to this, so we only need to get. And so if you look at owner detail view, I guess I should open up another tab. This is my arts owner detail view extends detail view, which basically demands a primary key. And so there is this primary key value. Ooh, don't do that. Don't do that. Undo. There is this primary key value that's going to come in, and that's going to come in from the detail view, which is the second parameter, which is forums, forum 3. Right, so we're going to go grab and load that object. I could have made that a getter 404. I probably actually should have made that a getter 404. So that's going to load the forum object, and the forum object is the title and the text and the owner of the forum itself. But then what I'm going to do is I'm going to say, go get me all of the comment objects filtered so that the forum value in the model equals the current forum. This forum, that is the forum we just loaded. That's the forum key in the model. So the first one is this forum in models, and the second one is this variable. I could have changed this to be, I'm not going to change it, but I could have changed this to be X. I could to change this to be X. I'm not going to save it, although it might be. Maybe I'll just save it. Make sure I got all of comment form. Oh, let's just make this be X2 because that's the variable. I hope I don't break the code by doing this. I'm trying to show you that this is a field in the model, and this is just a variable in this view, right? Okay, so this is going to give us a list of comments. In a sense, this is kind of like a list view. If you're dealing with a list view, you got to write a for loop to go through it in the thing. So we got all the comments for this thing, and we're passing in the comment form. That's simply constructing it. It's constructing this comment form. And then we're going to basically render the request. So we'll close that one. And so let's take a look at this detail page. This detail page is what generates this forum. A lot of it's pretty much the same. Check to see if you're the owner before you put up the little button, little pencils. That's quite nice. Print out the forum title, print out the forum text, print out this stuff is all the forum title, text, and how long ago with the natural time. So that's pretty straightforward. So that's really not all that tricky. So then what we're going to do here is if the user is logged in, and so it turns out that this does not require login, and so the only time we're going to show this comment form is if the user is logged in. So this part right here is if the user is logged in. BR clear equals all is what brings this stuff back to the left margin, even though I floated these things over using CSS. Load the crispy form tags, and then I'm going to build the form. That's this comment form that goes from the word comment, the text, the submit button, and the all forums, which is just an on-click JavaScript that sends us back to the all forums page. And that is the end of the user authenticated, because it turns out that seeing all this stuff, seeing the actual comments, that's okay. Non-logged in users can see it. And then if you recall, going back to the views, we sent in the comments, and the comments is a list of comments ordered by, in descending order, most recent first. And I guess you don't see it there, but they are most recent first. But at that point, we are just going to write a for loop to loop through all the comments, print out the comment text, print out the comment updated at, and if the owner of the comment is the current logged in user, put out a little trash icon. Okay? Put out a little trash icon. Got it? So that generates the output. That generates this page. But let's take a look at a couple of things that we're going to do. So you see first two things, right? We are actually going to post with action equals this form right here, the comment form, blah, does not post back to forums detail page. This is the forums detail page. If you look at it, it posts to forum comment create. So let's go back to that. Forum comment create is right here. And so it's just going to run this comment create view, passing in the primary key of the forum. Okay, so then if I go into my views, forum create, comment create view. So comment create view is what's going to happen when I get this post, right? So the post is going to come in. There's going to be a comment field, which is this text field, and there is the primary key of the forum, not the comment. So now we are going to make the connection. This is where we're actually making the connection. And you'll notice that I'm just saying login required view and view because I don't have an automated way to do this, and so I'm going to do it by hand. So we're in the post. We're going to go grab the forum object by a primary key. There I am using a getter 404, so at least I blow up in the right way. Then what I'm going to do is I am going to, let's go back to models. I've got to fill out the text field, the forum field, and the owner field. And the owner field are the two foreign keys. And, oops, come back. In the many-to-many, we have to have those objects available to us. So we are going to build a new comment that doesn't store, this doesn't store it in the database. The text field comes from the request post. The owner field is current request user, and the forum field, the foreign key in this middle connector table, is this forum object that we just loaded. And so that fully populates a comment object. It fully populates a comment object in that post method. And then all we have to do is we have to say save it. So the comment.save takes that in-memory comment that we created with the two foreign keys in the comment and sticks it in the database. And then all we have to do is redirect. Now what we want to redirect back to is we want to redirect back to this detail page, because we don't want to redirect back to ourselves, and we don't want to redirect back to all forums. And so we have, when we hit submit, we want to come back here. So it just looks like that thing showed up, but really it was a full request response cycle where it posted to comment create view, but after the post was done, it did a redirect. And we're doing post redirect, so it's cool anyways. And so this is a slightly different version of the reverse. It is the same concept as what we've seen all along, where we have like a forum ID inside a second parameter to the URL, because the reverse in this URL thing, I wish they'd call this reverse, because that's what it's doing. The URL is just kind of a wrapper for reverse. Well, this is the two parameter form. So we have a one parameter form of URL, which is this one, which says go URL forums : all. It says give me the URL to the view that is named all within forums. Here I'm saying URL forums forum create forum ID. This is saying this one needs a primary key, because if you go into urls.py, the forum create demands a parameter, and so we're feeding it. But you can also feed that in a reverse. And you do it with this funky format. I wish that was by position, but no, it's not. You have this args keyword, and it's sending in a list of variables, and the variable is the primary key, which is the number, which is this 3. So we're redirecting to forum/forum/3, and that's where the 3 comes from. Okay? Okay, so the only thing to look at next is what happens when I hit the delete button. So let's take a look at the detail page. So remember that we cannot delete in a get, but we have to delete in a post. Okay? So in here, this is the trash can. The trash can's not going to do the deleting. The trash can is going to link to forums comment delete with comment ID. And so there's this number 3, but each of these comments has a comment ID. And so let's just inspect. This is, you can see in the bottom, it's comment 7. This one is comment 4. And so that is the comment ID, because we're looping in this code, we are looping through for comment in comments, so each comment has the primary key. So with all that, I am just going to click on it, and of course we're going to have a verification page that turns the get into a post in a sense. I mean, it's just a page. And so we've gone to comment delete view. So forums comment 7 delete. And if you look at the urls.py, forums comment 7 delete, right? And we give it a name, and we're going to route through to comment delete view. So if we take a look at our comment delete view, well, what's pretty cool is that we can mostly use owner delete view, because by now we know it, the object. We know that we're in the comment model. The template we're going to work with is comment delete, which is pretty straightforward. Okay. So it's going to go find, and so you'll notice we don't have a get in here, we don't have a post in here, and that's because we're inheriting all that from owner delete view, the owner delete view. Now, the only thing we're overriding is the get of the success URL, because the success URL, when we're all done, we want to go back to the forum, not 7, but 3. See how we're going to go back to forum 3, and it looks like that just went away. And so the success URL actually needs to be computed based on the current forum. And so we are overriding the get success URL, which is part, not exactly of owner delete view, but the model's the generic delete view. We are returning a string. And if you go and you read self.object.forum, self.object points to the current comment. So if we're in the middle of comment for delete, while we're running in this view, self.object is the comment, right? That's number 4, comment number 4. But comment number 4 dot forum is the primary key of the forum that this object belonged to. By the time we're here getting the success URL, it's actually been deleted, but we still have an in-memory copy of it. So we're going to go to the forum's oh, no. I do not intend. Where was I? Yeah, I was dragging it by mistake, trying to highlight it, right? So it's been deleted, but we have it sitting here in the memory, and so we can get its former primary key. We can get the forum's primary key. Object doesn't exist in the database anymore, but the memory copy does, and so we know what that number is. So then we go to this fancy reverse again with a parameter, and so that's how we get back. Let's see what happens in the cancel. Cancel. Oh, so it's the cancel, right. So the cancel does this. The cancel generates the URL forum detail with a comment, which is the current object, and then a foreign key into forum and the primary key of the forum. So comment forum ID is what generates this URL. And there is that URL. It goes back to the forum detail page. So if I go cancel, it goes back to the right page. And that's because comment, you're walking the foreign key in this particular situation. So I think that we pretty much have covered let me just check the views. Yeah, we've covered pretty much everything that's unique in this particular bit of code. And again, the new part here is to have a connector model and then have a many-to-many field. The rest of this is very much similar to many of the other things that we have talked about. So I hope this has been helpful to you, and now you can start playing with many-to-many kinds of connections. Cheers.
Welcome to our lecture about jQuery and the document object model. So we've already been talking about some vanilla JavaScript where you have a script tag and you do document.write, and we've already seen how that can update a web page that in the process of being downloaded. Now with jQuery, well, that's been around for a long time, since 1995 when JavaScript was first created. But ultimately, we are starting to see more and more of the interactivity of our application being done in the browser. And so we're writing more and more code in JavaScript. Our classic request response cycle, we do a click, it goes in through urls.py, picks a view, maybe talks to the database, pulls a form in, and out comes some sort of HTML plus JavaScript comes back. And if you do a view source on a page, that's what you're seeing. And so the browser, when it receives that, it parses it and turns it into what's called the document object model. And that is a data structure that in a sense lives 1 pixel behind your screen. And then you see the results of the document object model. And so if you do a view source, you see the response. But if you do an inspect element, you see the document object model. And so what you see how the document object model can change. And the way the document object model can change is by you writing JavaScript code that does something to the document object model or reads the document object model. And so the JavaScript comes in as part of the response from the server, but then it starts to run. And then when it's running, in a sense, you're completely cut off from the rest of the server. You've got your response, but your JavaScript can still be doing work in the page. It can have events that trigger, it can modify the DOM, it can intercept clicks and run some JavaScript, etc. So like intercepting a click is like, that's an on click, which says run a little bit of JavaScript and then come back, right? And so we can even intercept a click, do something to it, and then stop the actual sending of the data to the server. So JavaScript is in a very powerful position in your browser. It's in your browser, and your page can be sitting there. And increasingly, we're starting to see folks build more and more of their application in JavaScript and less of their application in Django or in backend. And so what we're finding over time is that the JavaScript is kind of talking to the models directly, and we'll talk about that in the next lecture, right? The JavaScript talking to the models directly and then putting stuff up on the screen rather than going through the entire request response cycle to get a page back. And so this is hybrid application. So now what we're going to do is we're going to really talk and focus much more on this interaction between JavaScript and the document object model. So document object model is a concept that's been around for a very, very long time. When JavaScript was created in 1995, in order for it to have access to what was on the screen and change what was on the screen, which was its goal, we needed a way. And so they create this variable called document. And the document is always there, and then you call methods and change attributes, and then you get back elements, like a paragraph is an element, and then you can change the color of the paragraph, and you can do all kinds of things. You can even insert new paragraphs. And in 1995, as the browsers were saying, do I want to add this JavaScript, they actually already had document object models, but they weren't the same. And so the idea that all the browsers would agree on one document object model, that just was not practical at that time. It caused for a lot of pain from 95 to 2005, 2006, and we'll talk about that. But the document object model has never been, every bit of it is not forced to be a standard. And so we have parts of it that we make be a standard. So in the first part of this, we're going to talk about not jQuery, but instead what the world kind of calls vanilla JavaScript. And that's sort of JavaScript that the browser gives us versus JavaScript that we can write if we have the jQuery library installed. So we're going to talk a little bit about vanilla JavaScript. So one of the choices they made back in the day was, in order not to have to look at the DOM directly, we would just say, look, bypass all the shape of the document object model, which was a hierarchical set of trees and tags. Say, look, we're going to put this ID field on a tag, and then we're going to give document.getElementID as a way to look up and get our hands on a tag, and then